and all online audience hear me? Okay, so welcome to the Exploring Data Forecasting, Product Recommendation and NLP Technologies and Application webinar, co-organized by Hong Kong EBA today. I'm today's moderator and I'm also the representative of HKEBA. I'm Tim. So this materials and event is funded by the Professional Service Advancement Support Scheme of the Government of the Hong Kong Special Administrative Region. Any opinions, findings, conclusions, or recommendations expressed in this material or any event organized under this project do not reflect the views of the government of the Hong Kong Special Administrative Region or the vetting committee of the Professional Service Advancement Supporting Scheme. So this project, we aim to equip Hong Kong ICT professionals with knowledge on the latest digital transformation trends and also the implementation strategies. Also, we're eager to help ICT professionals on knowledge and understanding of the different types of NLP, data forecasting, and product recommendation technologies and relevant applications. Special thanks to collaborations supporting organization under PSS for reviewing materials and also approve that they are suitable for IT professionals. Okay, so before the start of the webinar, let me introduce the background of our association. HKEBA stands for Hong Kong E-Commerce Business Association. We are a non-profit organization, and our mission is to upskill Hong Kong SMEs to catch up with the trends of digital transformation. And also, we hope to nurture a world-class e-commerce community in Hong Kong. So we have several partners and supporting organizations. Our projects are mainly funded by the Trade and Industry Department and also the Vocational Training Council. At the same time, we have different associations, chambers of commerce, enterprises, and also e-commerce platform are our partners and supporting organizations, such as WTIA, Asia Rate, Hong Kong Management Association, Shopify, GoJoy Travel, etc. So at HKEBA, we have a wide range of offerings for corporate and also individuals. We run local events such as seminar or webinar in a regular basis. We will invite some of the reputable corporate to share with us on the marketing, innovation technology, and also some of the e-commerce platform related informations. So in the last few months, we have co-opted with Adobe, Ricardo, SAP, Google Cloud, AWS, etc. And also we brought our corporate members to on-site tours or have a regular networking dinner or luncheon. So we have brought our members to the airport authority and also the hospital authority to check on their latest technology application on their daily operation and their daily workflow. Also, we will have a monthly networking event together and also to connect talent and specialists from different industry or mainly from the e-commerce industry. We hope to connect each other and helping them to explore potential for business collaborations. So before COVID-19, we have brought our members and also different corporate members to overseas delegations tour to Taiwan, Vietnam, Thailand to check out the local market development and also any latest technology they have applying in their local market. We also provide you with some of the useful tips and articles, tips for setting up an e-commerce platform, and the latest information about the industry's innovation and technology tours. We also have a lot of industry expert and some of the top management level stakes will share with us their experiences and also their insight about the latest trend of digital transformation. We'll also promote some of the iconic events of our partners. So we hope to do all kinds of things to connect all talent and specialists within this industry. So finally, if you are interested in our association and want to know more, or you are looking for digital transformation opportunities for your business, feel free to contact us through our website, and our staff will reach you out as soon as possible. We also cover different training courses. So on the slide, you can see we have e-commerce training course, digital marketing, CRM, coding and development, marketing automation, data science, cybersecurity, and also cloud application. So if you're interested to develop your skills in this kind of scope, and you want to upskill your skills related to this kind of aspect, so please reach us. You can follow us on our social media, or if you have any inquiries, please email to info@hkeba.org. So I will now stop at this live for a few minutes. You can scan the QR code here to subscribe to our social media channel, and also you can subscribe to our monthly newsletter list. Okay, thank you very much for following us on the social medias. So let me summarize a bit about today's webinar objective. We hope to empowering Hong Kong's information and communication technology services through sharing the latest digital transformation trends and implementation strategies, enhance the standard and external competitiveness of Hong Kong information and communications technology professional services by updating ICT professionals on the latest trend and technologies in AI, extended reality, and also blockchain technology. So I will talk about today's webinar rundown. For part one workshop, we will learn about knowledge related to application of machine learning, data forecasting, NLP, etc. We will mention some of the retail case sharing in machine application, process of running a machine learning program, data collection, construction, and how the cleaning of it, transform all the data for the purpose of ML model, and some of the ML feedback loop for improving the accuracy of data forecasting. And also we'll have some demos on or examples of how product recommendation is used in e-commerce and retail. So we expect you to learn the points you now showing on the slide. We want you to know the application of ML, knowing some of the retail case sharing, the process of running through a whole ML cycle, how to frame the problem, how to do the data collection, do the construction and cleaning act, how to train and select your ML model properly, how to improve the accuracy, what kind of action you have to do. Some of the demos and also some of our speakers will cover the ethical issue behind machine learning. So I'll now briefly talk about 4 of our speakers today. So the first speaker is Sunny. Sunny Wong is the Director of Product Development of Sell Software Limited and also chatbot.com.hk. Sunny has been involved in the development projects of Cantonese chatbot and eager to expand its application in retail context. Founded in March 2015, Sell Software is a leading bot maker in Hong Kong, offering artificial intelligence solutions for enterprises to build conversational digital assistants across various message platforms. For our second speakers, Terence is now the Vice President of Business Consulting of Funnel Labs. Terence had worked in several international speech companies specializing in NLP and analytics technologies. He has 15+ years experiences in providing contact center solutions, ranging from chatbot, voicebot, speech recognition, NLP, speech analytics, and voice biometrics solutions. So Funnel Labs is one of the leading AI companies in the Greater China, with specialists focusing on AI technologies to help enterprises with customer service, compliance, and other lines of businesses. Our first speakers, Mr. Chow Wai-hei holds 5+ years of experience as a solution and engineer architect, holding experiences as a solution architect in PCCW, Macroville Telecom, and now working in Amazon Web Service. Mr. Chow has various certifications ranging from developers, systems, operations admin, solution architect, etc. So launched in 2006, Amazon Web Service began exposing key infrastructure services to businesses in the form of web service, now widely known as cloud computing. The ultimate benefit of cloud computing and AWS is the ability to leverage a new business model and turn capital infrastructure expenses into variable costs. And our first speaker, Mr. Chow, has also brought his colleague to today's webinar. Mr. Choi is a machine learning specialist, solution architect, also at AWS. He started ML research earlier and has several years of experience building artificial intelligence powered industrial application in computer vision, natural learning processing, and also online user behavior predictions. Our final speaker, Dr. Ming Zhang, also holds more than 5 years of experiences in the field of deep learning and big data. Ming has more than 30 publications in top international journals and conferences in the area of multimedia, big data, social network analytics, and deep learning. Okay, so before I invite Sunny to present for us, I want to have a brief introduction on today's topics. So if you ask me what are NLPs or data forecasting related topics, I would say I can see the escalating importance of NLPs and also the customer experiences. I can see the relations of these two kinds of items and So we always ask about how businesses can benefit from the escalating importance of NLP. So while some customers' inquiries are pressing and warrant human understanding, a large portion of these routine inquiries actually sometimes don't require any agent assistance to be resolved. Maybe some of the customers are asking very simple questions. But if lacking AI-powered technology, you have to spend a lot of human resource, especially if you are hiring agents, you will spend a lot of agency resources to handle this kind of inquiries. So having the AI chatbot support the customer services by automating different routine inquiries and utilizing NLP and chatbot by analyzing the keywords, the search intent, the grammar, and also the popularity of the populations. This helps to deliver the most relevant, no matter search or a result or answer directly to the inquiry customers. And from an external perspective, customers no longer have to wait in phone lines because they have engaged with a channel that suits their inquiries. This reflects quite positivities, no matter you can instantly deal with the customers and you can 24/7 to capability to handle your customer inquiries compared to the traditional human to human answer. So let's now invite our first speaker, Mr. Sunny Wong, the Director of Product Development of SetSale Software and also chatbot.com.hk to present for us. So let's welcome Sunny. The camera is here.
All right, thank you, team, and thank you, EBA, for organizing this seminar. So I'm Sunny Wong. I'm co-founder of SetSale. We are a company that specializes in smart contact center solution and building virtual assistant for enterprises to handle customer service and after-sales services. So in today's sharing, I will briefly introduce our company. We'll also introduce you some of the business showcase and retail cases we have done in the past. And then we'll go through a pretty detailed workshop on how to build a simple NLP model. And then at the end, I will talk about some of the best practice for your companies to build NLP applications that would be beneficial to your business use case. So SetSale was founded in 2015. So we have more than 6 years of history in building virtual assistant in Hong Kong. So far, we have deployed more than 70 virtual assistants in Hong Kong across many different industries. Annually, we are handling around 100 million inquiries over different channels, including social media channels, emails, voice, and websites. We finished P-Series A funding last year, supported by Asia Pay Capital. So this is some of the clients we are serving. As you can see, chatbot or NLP technology is widely used in Hong Kong nowadays. As you have touch point in many different customer service, you may have encountered a very quick response on CS, and this may be generated from a chatbot. So for example, companies like financial institutions, like Hang Seng Bank, Bank of China, BCT, Shanghai Commercial Bank, Zhong'an Insurance, also using our services. Retailers like Pizza Hut, KFC, L'Oreal, Kia, they are also using our automated channels to handle P-sales inquiry. And also a lot of public services like HKTDC, CLP, or HKUST using our service to handle inquiries with the general public. So this is just an overview of what our solution can do. Essentially, we are a contact center solution, meaning that we build solutions to handle pre-sales and after-sales inquiries. So on the top layer, you can see that we can connect our solution with majority of the channels that you expect your customer to contact your business, including different social media channels such as Facebook, Instagram, WhatsApp, WeChat, and also like website and mobile apps as well. And sometimes you also interact with customer through email channels or IVRS channels. So our company also can handle inquiries automatically over these kind of channels. So the idea is really to have one single platform to manage all your inquiries with all different channels. So regardless of how the customer interact with your business, either it's from WhatsApp or is it from email, they all go into the same platform, which is our AI platform. And our AI will try to understand what the customer is asking. Maybe it can be a simple inquiry like, what is your store opening time? Where the chatbot can immediately provide a response to this kind of inquiry. And then maybe some people may ask about the status of their delivery, and the chatbot can extract different information from your backend system. For example, like your inventory system, your booking system, or your CRM system to reply for the users that, okay, your order is actually on the way and to be delivered today or tomorrow. And then the third type of inquiries is more complex or more sophisticated that require human agent to reply. The chatbot can actually try to understand what kind of topics people are asking and relate to different service teams for live chat support. So it means that our solution can handle 100% of inquiries incoming to it in different channels. When you start building chatbot, maybe at the very beginning, the AI can only handle 50% of the inquiries, while the rest will be related to a human agent to answers. But over time, actually, the AI can learn from the human counterpart on how to handle different inquiries, can improve the containment rate from 50 to 70 to 80%. In some of our cases, we even can handle over 90% of the incoming inquiries. So let me show you a little bit on what we have built over the past. And one of the showcase is Dory, right? So Dory is a chatbot made by Hang Seng Bank in collaboration using our technology from the natural language processing. It's one of the more popular chatbots in Hong Kong with over 250,000 users. The goal of this chatbot is actually to do engagement on Facebook, where all the cardholders can interact with this chatbot to get recommendations on dining, on traveling, on shopping suggestions. Because Hang Seng Bank has a lot of merchants, and each merchant have a huge amount of SKUs or items to sell. So the NLP is actually a very good use case for this kind of a project. So let me show you what NLP can do for this kind of solutions. So to give you some understanding of what NLP can do, the idea of using NLP is actually to make your application that can interact with users more naturally, right? So before NLP, if you want to do a product search or you want to do a recommendation engine, you normally have to ask the users for some tagging or some labeled categories. Like you may have a website with drop down on different categories on the spending and on different options or criteria for the users to make a search, right? So this is rather cumbersome, and this is rather difficult for the users to navigate your whole database and explore naturally what they are more interested in, right? So with NLP, basically you can ask the chatbot or ask the virtual assistant any open questions. For example, here you have a case like, 我想食麻婆豆腐，附近有冇啊？ In English, it means that they want to have a mapo tofu. Is there any restaurants that nearby ordering this dish, right? So the difficulty you immediately see is that how you can associate this dish, mapo tofu, right, with 100 restaurants in your database, right? Maybe some restaurants offer mapo tofu or some restaurants offer different cuisines, but you do not really have the menu items on this restaurant in your database. It's almost impossible. Most of the merchant database do not have this kind of information. But it's rather common sense to us, to us human, that, okay, properly like Sichuan cuisine or some kind of Gingchen cuisines restaurants would have this dish, and this would be common sense for us to recommend this kind of restaurants to the customer asking these questions, right? So this is really where NLP can help your applications to have a more natural or human-like interface that can do recommendation to users based on conversation between human beings, right? So this is essentially what NLP works in practice. So for example, when the NLP suggests a digestive inquiry, we will try to understand what kind of questions it's asking. So there's a two problem to be solved. One is a classification problem, and one is an information extraction problem, right? So for the classification problem, is rather straightforward. Basically, we want to classify what this user is intending to do, right? So here you may classify them as, okay, they're actually looking for restaurants recommendations, right? And suggesting for nearby place that has this kind of dishes. And another part is the information extractions. And this part is more complicated. For example, you would have a NLP understanding of mapo tofu is actually related to a dish below Sichuan cuisine, right? And from there, you may expand your concept from Sichuan cuisine to Chinese cuisine, or like a Beijing cuisine, or somewhere near around this area of cuisine. And even more important is that you may understand some brands of the restaurants that may offer Sichuan cuisine in Hong Kong, right? So actually, when we talk about one word like mapo tofu or a specific dish, the NLP will be able to expand this concept into different concepts or ideas. Right? And these concepts or ideas will be useful for you to be passed through to your search engine or your database to expand your search for example, like Sichuan cuisine or Chinese cuisine, where it's more likely to return a result for your query. So here basically it said that, okay, it understand your problem is asking for recommendation for particular restaurants. And the VA can answer that, okay, I understand what you're asking, and maybe I need to know where you are because you're asking for a location, right? And this is what we mean a context, right? Context is that you may have a previous context coming in that the NLP do not understand, right? It's because you're asking for location, but I don't know where you are. So I have to ask you where you are in order for me to suggest a location for you. So at the end, you understand that you're asking for a location for a nearby restaurant that offer this mapo tofu dish. And it understand that you are asking, the dish you're asking is related to Sichuan cuisines or Chinese cuisine, right? And at the end, you can ask the users to share their location and basically do a recommendation for them. Okay, you are in Tsim Sha Tsui and you call the OpenRice API and putting the field like food type is Sichuan cuisines and district is Tsim Sha Tsui, and you return like 200 restaurants for them to choose. Right? So this is a very common NLP problem where I have briefly introduced three main concepts, right? So the first concept is the intention of what the user is asking. In this case, they're asking for recommendation for restaurants, especially like a location for location. And secondly, what we call entity extractions or information extraction from your query where there's a specific information to be extracted, right? So here you have the user has actually mentioned a dish, right? And the dish has different concepts behind. The dish may be related to Sichuan cuisine, maybe related to a different brands, like or related to Chinese cuisine. And the third part is the context of this inquiry. The context of this inquiry is asking for a location, but it is missing from this conversation. And that's why the AI has actually to generate a new query to ask the user, okay, actually where you are, in order to complete the product recommendations, right? And imagine a different scenarios where the users do not ask for a dish. They may just ask for, is there any good restaurant around my place, right? So you run into the same problem, but you do not have the information about specifically a dish, right? But you still have a missing context and you know what the user is asking. So the logical response for the AI is actually just to give the recommendation for the users based on his location. So that's the first use case, that how we use NLP to make a more, I would say, conversational dialogue with the users to help them to find what they're looking for. Okay. So the second part of recommendation is a bit more challenging. Here, the user asks about questions like, do you have LV nearby, right? So here, a lot of the time when we do a search engine and when we do product recommendation, it's really, really difficult for the engine to understand synonyms or acronyms that means certain brands, right? So the first challenge here is that the NLP has to understand what LV means. So if you do an NLP embeddings or word embeddings, you actually can get more information from this topic. And I will introduce what word embedding means later. So in here, LV actually means LVMH, Louis Vuitton, Loewe YC, right? And you extract some information from there, but you still do not have a concrete understanding of what that is. You may already use this tag and put it into your database and see if there's a hit, right? If there's a hit, then you can return, hey, this is a store nearby you, and that's the done of the recommendation. But most of the time, people ask about stuff that do not exist as a structured data or structured label in your database, right? Because your database is a structured database, and meaning you may only have a category of like luxury goods. You may have some name of the merchant, but it's not exactly matching the query of the users who are asking these questions. So it's really important that the NLP can expand this single word into a concept net, what we call, right? So here they have managed, the NLP can expand the understanding to, okay, actually LV, this brand is a brand type, but this brand is also closely related to other brands, such as Chanel, Burberry, Hermes, and also it can extract more understanding that it is part of the category of luxury brands, it's part of fashion brands. And also under this brand, it offers products like handbags, wallets, accessories. So you actually have a more 3D understanding of what LV means. So on that word itself, it means that it's a brand. It has different acronyms, synonyms to this brand. But on top of this brand, you have the category. It's under a category of luxury brands, under a category of fashion brands, and it sells products like handbags, wallets, accessories, and horizontally is related to other luxury brands like Chanel, Burberry, Hermes. So now you have way more information you can work with. You have basically a lot of more meta label, what we call meta labels, that you can feed into your database to see if there's any recommendations from your database. And most likely in your database, you will have some kind of categories, or you will have some kind of brands that match these related brands names. For example, your database may actually have Chanel, or maybe you actually have some brands under luxury goods definition or categories. And so the suggestions or like the recommendation engine can actually make a pretty smart response and say, oh, sorry, we don't really offer LV products here, but I have found very similar items for you. And you can show other brands that belongs to consumer goods, luxury brands, or you can show the brands very much related to Chanel and Burberry and Hermes. So this is another use case on how we can use NLP to pre-process your inquiry and expand the understanding of the words before you do your recommendations, right? So this is a very simple application of NLP on how you can use the simple word embeddings to expand your search in order for your database to return more sensible or more meaningful results. So with Dory, we have actually done a success story in Facebook. Dory has over 80% registration rate over the period of 3 years. So basically, when we push any notification or push any recommendation to the users, 86% of the users will actually register for the offer. So this is a very high success rate because of the fact that the AI can actually understand what the user is asking, and they will only promote the products that are most relevant to the users. So with AI, you can really build personalized experience and one-to-one dialogue with different users. And basically we'll have a recommendation, has a promotion to them, which are different from all other users. Okay. So in the second part, I will briefly introduce a tutorial of how you can build a very simple recommendation engine using NLP. Right? So it includes some of the codes, or it includes some of the steps, but I think this is a very simple and very straightforward way to understand how you can build a small application within 1 hour or 30 minutes. So normally, if you build an NLP recommendation engine, there are 4 parts of your process. The first is to collect the data you want, and then you pre-process the data. And third, you run some kind of models, regardless of a classification model or extraction model, that help you to predict output based on a future inquiry, right? And the fourth is basically build the API and display the results in a meaningful manner. So here is just a small example on how to build a recommendation for videos, for example, right? So if you go to YouTube, at the homepage, you normally have a recommended videos that YouTube suggested to you, right? So of course, the algorithm of YouTube is much more sophisticated, but in a nutshell, it basically understands what you have watched and understand what your interests are, and try to recommend stuff that are more aligned with your interests, and so that increase your possibility of clicking these recommended videos, right? So here, the first step, as I said, is to collect the data you want to build the model on. And actually, one of the very good resources is Color. So I put a website link here, and you can basically visit the site and see what kind of data sets they have. They have over 1 million data sets. So it's a really good starting point for you to build something very simple. So here, in this case, we have used the data set called movie titles. So here, they have over 600, 700 different movies that you can download as a title, as JSON. So it's very simple to just go and download this data and use it for your machine learning model. And then the second part is pre-processing. Pre-processing is a very important concept in natural language processing. Because basically, if you have very high quality data, and if you have unstructured data, then it would be very important to pre-process what you have. But here, we already have a very good data source, which from Kilo, so we don't really need to do a lot of pre-processing. We just need to remove all the special characters, remove and make them lowercase before we feed into the model to train. And before I go into the details of what the model does, I would like to introduce you some of the concepts in natural language processing. So one of the topics I have mentioned before is word embeddings, right? So if you imagine NLP as a machine learning model, it actually at the end would vectorize language into a vector space, right? So word embeddings is actually a way to put different words into a space that is numerical, right? Because if you don't do this, the machines cannot understand words, right? So first, you have to translate words into numbers, right? So the way word embeddings do here is basically they put similar words, like for example, greeting and speaking are very similar words. Obama and president is similar words. So they put all different words into a vector space, and all similar words would be close together. So this is a very useful pre-processing layer for NLP to understand what is the similarity between one word to another. Right? So, and there are many different models to build this kind of word embeddings. I will introduce you one of them, one of the more popular ones. And you can just basically take this and use it right away. If you would like to understand more how to build this kind of word embedding models, there are a lot of resources on Hugging Face, which is an API provider for NLP, where you can learn how to build different word embeddings models. So here, you just need to know that word embedding is basically a technique to map vocabularies to a numerical space before you feed into the NLP model for machine learning. And here, there's an example from TensorFlow, which is really good. This is a website called TensorFlow Projector, where you can just play around. As you can see in the middle is the vector space. So you have different words mapped into this space. And basically, you can play with this model and put in different words here and see what is the most similar ideas, concepts that's come out from this mapping. And they have also trained many different models, so you can compare which model maybe really works for you. Okay, so the second idea I would like to introduce for you today is BERT, right? So BERT is language model published by Jacob and his colleagues from Google. Essentially, Google used this model nowadays in its search engine. Right? So when they published BERT, over almost 11 NLP models has reached a higher score using this model. So it's really a breakthrough in NLP in understanding natural language. Right? And after 2018, you have many different models that improve on BERT and basically achieve state-of-the-art accuracy in many different NLP applications. And BERT is nowadays used in Google search engine almost all the time. So if you type in any inquiry on Google, they will use BERT to try to understand the concept and understand the meaning of what you're trying to search. So it's a very essential milestone in NLP development. And I think if you are first coming into this space, I think this would be a very good starting point for you to use and for you to build some very useful application right away. The way BERT works is that Google will publish a pre-trained training set, a pre-trained model, where you can just grab it and use it to for your business applications. And there are some very good applications that are used by BERT in solving. So for example, question answering, like virtual assistant, text classification, like if you have many different unstructured documents or unstructured text, you can use BERT to classify into different categories and try to understand what each topics are. Right? And then, because BERT is basically built up on a mass data, and it basically built on the next sentence prediction. So for example, if you have a chatbot that asks the question A, and then you can use BERT to guess what is the next question that is most likely to be the following questions. And some of the people just use the pre-processing layer of BERT, for example, in tokenizing your sentence. Tokenizer in the sentence means that you break up the sentence into different meaningful words. For example, LVMH is basically a brand. And so you can use it to build some small applications to understand the truncation of different words, and you can extract different words for your application. And then the last is the embeddings, which I will use for this tutorial. So what I have introduced for you is two concepts. So the first concept is word embeddings, and the second concept is BERT, right? So here, which is the most interesting thing that is happening, is that we actually use BERT embeddings to create a vector space, as I mentioned, to create a vector space to understand what the movie's title are most similar to, right? So this is almost like magic. So imagine you just put in a word like Phantom of the Opera. So it will immediately output all the similar words, like it's musical, it's related to Broadway, it's related to different actors and actors. It's really, really fascinating of how far NLP has been developed. And you can just use it right in the way to call it using one line of code and to put in a word, and then you can have all these expressions that comes out of the model. So once we have the embeddings, we have the numerical vectors built into this line. The last step is to package it as an application, or package it as a service, what we call. So for all machine learning model, you have an input and you have an output. So here we will use the encoding space on the input interest. We also ask the users, okay, what is your interest, right? And then we have also the embeddings of the inputs, and we have compare. We can use a similarity function called cosine similarity, which is very simple. We basically compare two vectors and see which vector is most similar and return all the similar results. So let me explain a little bit more, right? So the embeddings return all the vectors which are very similar to your inquiry, but you still have to output what the words are for your similar vectors. So here, basically, we ask the users to say, okay, what is your interest? Ask for the users to input one word. And then we use the word embeddings provided by BERT to find all the related topics, find all the related concepts that are very similar to these input words. And we output all the concepts that are very similar to these input words. So essentially, we use BERT as a language model to understand one word and find all the similar meanings of the concept of the words. And here is basically what the output is. So here, people just input action Hollywood thrillers, and they will output all the similar movies based on the training set of the from catalog, because you have labeled all the training set of different topics, right? So you have Shadow and Bone, which is pretty good, right? So you have Transformer, DC Gorilla, which is a little bit weird, I think. But I think you can get the hangs of the output is very relevant to your input interest. And also you can try something else, for example, like Arsenal, Europe League, Premier League, and you can find all the related movies that are related to this interest. And the last example is music, Taylor Swift, Imagine Dragon, and you can find all the different music videos and lyrics from YouTube based on this. So this is already very similar to how you can build a recommendation engine based on just a few key interest topics. So imagine if you have on your website, right? Imagine you have a website, maybe you are an e-commerce company, or maybe you are a product company, or you have different service company. You already have all the clicks, or you have all the browsing data of different users. You kind of understand what people have already looked into. Maybe they already looked into one topics of your offering, or one categories of your offering. But you have a huge database, like maybe, for example, maybe you are e-commerce platform with 100,000 products. It would be impossible to build a rule-based recommendations to understand each word and try to link up different categories based on the users. And it will look very cumulative, right? Because if the users have browsed different offers, they have browsed different topics, they have browsed different titles, it would be almost impossible for you to define all the logics for your recommendation engine. But with this kind of approach, you can basically train a model based on what you have here and extract the embeddings from all your topics and find the most similar one that is fitting to what the user is interested in. So if you have a topic that, for example, is Chinese food, right? So if the user has brought a label of Chinese food, and they can find all different embeddings, and basically you can do a very simple recommendation like this that can suggest similar topics, similar authors that also write books about Chinese food, or they have mentioned the cuisines in their comments that they are talking about in their books and stuff like that. So the understanding is much more deep, and the way you build it is unstructured. So it's rather simple that you can build something like this in 30 minutes, and that look like a pretty good recommendation compared to you have to build all the different rules and logics to try to do a recommendation engine based on. Yeah. So this is just a simple example of how you can build a recommendation using embeddings in 15 or 30 minutes. There are a lot of other applications in NLP nowadays that use BERT or any other different models commercially, right? So the first is most important is language translation. And the second one is question answering. So meaning that when we do a query, like for example, like search engine, right? So you have a passage of text, you have a menu, you have a, let's say you have an HR menu, and people may ask, how many leaves can I apply for, right? And the model can read your HR menu and find exactly, okay, for staff who have less than 5 years of experience, you have 15 days of annual leave. So this is some kind of application the NLP is normally using. The third part is social media and monitoring. This is also very useful for a lot of things. As I mentioned, if you use word embeddings, you can already use the NLP to understand all different words. And also with the name entity extraction, meaning you extract information from your query, you can see what kind of topics people are talking about on social media. So sometimes we do chatbot that listens to what people are commenting on the post. So the way we do it is basically to understand maybe they're asking for complaint or maybe they're asking for refund and stuff like that. And we actually escalate this kind of inquiry to the inbox or live chat team to handle. So we don't want people to really complain in public channels because no one is really helping them there and they will keep complaining. So when we do social media monitoring, we see that, okay, this customer is not happy about your service, we will immediately escalate to a service center and try to help them by watching what they are posting. Right? Without that, basically people will just keep commenting, and if nobody is watching this post feed, and people will see, okay, your brand is actually not very good at customer service. And the fourth application is target advertising. So it's similar to how we build chatbots and target promotions. The first step is to understand what the user is interested in. Again, you can use classification techniques, you can use embeddings to understand, to extract what is topics people are talking about, what topics people are interested in when browsing your website, right? And after that, you can specifically pinpoint what kind of promotional material you will push to the users, right? One very interesting concept is that we do automation for milk powder company, right? So a lot of the times, customer may ask different questions like, okay, what kind of milk powder is best for the babies? What kind of food I should have for my caring of my baby? So this is also actually very important to understand what they are facing, what kind of stage they are facing, and what kind of interest that they are. Because if you understand what they're looking for, you can basically pass through information or content for them that actually really answering what they're looking for in your services, in your products. And with personalized content marketing, the open rate or the click-through rate is almost 70 to 80%, which is huge compared to if you push a random promotion message to every audience in your group, and the open rate is normally just 1 or 2%, which is really effective and offensive to a lot of the customers, right? The fifth point is grammar checkers. I think one of the very good applications using ML in grammar is Grammarly. So basically use machine learning to help you check your grammars. And grammar checking is actually state of the art in machine learning, meaning machines are doing much better work in making grammatically correct sentences than average humans. So 6 is text and other summarization. So this is important for search engine, right? So imagine you are a large company, you have a document engine of over, let's say, 1 million articles, including manuals, brochures, leaflets, email communication, stuff like that. And you just want to do a search, maybe like what is the sales revenue of my annual return last year, right? Something like that. And there's really no very good way to do it, right? Unless you have labeled all your documents with very clean data label, like, okay, this is report from finance team over by this staff in a time period of from X to Y with these topics, A, B, C, D, E. Unless you have labeled all your documents, then your query is actually not very hopeful in finding the document you're looking for. Right? So with NLP, there are 2 ways that can help. The first way, it can actually generate all these meta label for your documents automatically. For example, you can know what kind of topics this document is about. Right? For example, you have HR guideline or HR manual, you can extract, oh, okay, this manual is about annual leave, it's about compensation for leaves, you can about maternity leave and stuff like that. You understand what this article is about. And also you can extract specific information about who writes it, when is it written, what kind of topic is it about, where is it stored, what kind of security or confidentiality is from. And you can generate all these meta table, right, for this document automatically. And on the other hand, when you do a document search, when you just type in anything, like I'm looking for policy about maternity leave for guys, for male colleagues, something like that, right? And the NLP on that side can actually classify this inquiry and extract information from the query. Okay, this is asking about maternity leave, especially for male colleagues and stuff like that. And then you can do a much more meaningful search, because you're already on the left side, on the document side, you have all the metadata generated. And on the query side, you understand what what piece of information is important from the query using natural language, right? So you can do a recommendation for them. Oh, I actually found these 5 guide manuals for you. And I think the first one is most relevant. This is the HR manual, most recent HR manual. And on page 7, item 4, it mentions about maternity leave for both female and male colleagues, right? So this is something that is very useful for NLP to understand a huge amount of textual data in a large database and find the most relevant information for the users based on natural language. Okay, number 7 is the information extraction. This is one of the topics that we encounter quite frequently in commercial topics. A lot of the time, companies have collected a huge amount of data, like maybe it's a live chat service ticket, or maybe it's a call log from between all the customers and all the agents. It may be all the financial data, maybe you report all the finance data, and they are largely unstructured data. Unstructured data means that you don't really label this piece of data as a category or as some keyword and topic and stuff like that. And a lot of the time, there's no use for such amount of large data. It's just sitting in the data warehouse of the companies for ages, and nobody is making use of it. But NLP is it's actually a very simple application for NLP to just input all these documents like live chat. For example, live chat is a very important topic. We can just input all the live chat of this company to an NLP model and extract all the different concepts from every piece of articles. Okay, this live chat support is about printers, right? Is the printers are out of order from this team at what time, and it's critical, right? And basically, you can do an engine and asking the AI, okay, last year, how many printers broke down and stop us from selling stuff, right? And the NLP would say, okay, 30% of your service actually encounter this problem. So this kind of translate meaningless and structured data into a meaningful business insight that can be used in your decision making or in your prediction of your business problem. Right? Number 8 is document search, which I already mentioned, so I will not go for again. Okay. In the next part, I will discuss a little bit about management or project management of NLP projects. So normally there are 4 phases in NLP projects. So the first is the design phase, and second is training phase, and third is the testing phase, and last is production phase. Very important is the design phase. You have to understand what are the key performance indicators of your model trying to solve. Right? So you work with users to capture the the results application. How does it look like? What kind of query? What kind of input? What kind of UI, UX the application has to look like? And then the training phase is basically try to train the model to achieve this kind of KPI. And there are many different KPIs that you can use to benchmark or assess NLP model, which I will not go into details. But on the third phase is testing phase. Normally for machine learning project, it's important to use an iterative approach to test the application, meaning that you first test with the users, collect test cases from the real world, and then you label or use your KPI to assess how good this model is. And you may have different models and you may have different results, and you try to fine tune your models to arrive at the best result that is ready for production. And from all these four phases, actually production is the most important phase. Because for machine learning project, 80% of the work done is not from this first three phases. It's actually from the production, meaning that the machine learning project must continuously improve over time, meaning that you may have a model that actually try to capture real life data, and there's a process in place that improves the model over time. Okay. So this is my last part of my sharing. So I will just share some of the best practice for virtual assistant implementation. Virtual assistant is really the expertise of what we are focusing on, and Zexcel, our company, is focusing on. So this is just a few highlights of what we have learned so far for managing over 100 million inquiries every year. The first is really important. For all tasks, machine is really good at doing repetitive tasks. So when people think machine learning can do everything, it's normally not true, and it will set the bar too high for any project to go into production. Focus on the task that is simple, that is repetitive, and that cannot be done by humans, or at least not fun for the humans to do over a large quantity of data. Right? Focus on these tasks first. And second is arrive with a KPI at the very beginning of your design phase. Meaning that, okay, if you have a chatbot, for example, to answer simple inquiry on the refund process, you may set a target, okay, out of 100 people who went into this journey, at least 80 of them are happy with or can finish the refund journey. And you may ask, okay, what about the 20 fail case or 20 case that cannot go through? And that will bring me to my third point, is that for all machine learning application, you must have a plan for the human agent to interfere or to work seamlessly with the AI to solve 100% of the problem. From our case, it means that if there's some case that require human assistance, regardless of maybe the system does not support it, maybe the situation for that inquiry is too complicated, then the AI must have a way to seamlessly hand over to human to handle. And the human can handle within the sessions, and they can reply through the same channels the people is asking the chatbot on. Right? So for the users, they actually do not know if it's handled by a chatbot or a human agent, but 100% of them, whatever they ask, it gets resolved within the same channel and in a timely manner. And the fourth point is to personalize your experience. As I said, when a user comes into our channel, if you already understand what the user is asking using NLP, what the background of this user is, maybe they are VIP for your business, what kind of purchases they have done in the past. For example, they have already bought X, Y, Z from your stuff, from your stores. Then you can build your model to understand the context or the different particular information of this user and make a response much more tailored. For example, people may say, oh, I want a refund, right? So if it's VIP and you say, okay, sorry about that, your VIP customers, I see that you have bought X over the last day. Do you want to apply for a refund? Yes, no, and stuff like that. So this would be a really good example to personalize your response based on the information or from your data source you have. So when you build a machine learning application, it's really important that this application is not a standalone application. It can connect with CRM, you can connect with different in-house inventory system, so the AI can actually get more data to handle this inquiry. And then last one is to collect data at scale. It means that if you are not collecting data from your customer support, for example, when people ask you about certain things, you should have collect this data over time. Even if the data is not labeled, it's not structured, you should collect the data. Of course, personal information is point to note, but normally there's a lot of machine learning model that can remove personal data from your large quantity of data. So you can store at scale without harming or without potential issues with personal data. The second last is to plan for omni-channels, right? The reason why we want to build a natural speaking AI is that when you build the AI on one channel, like for WhatsApp or for WeChat, you can actually easily expand this application to all different channels, regardless of its social media channels or email or website or application. So you all have the same AI serving all different channels at any point of the time. Before that, if you do not have AI, you basically have to go through UI development, backend development for each channel. You may have an app for your website. You may have different journeys for your WhatsApp journey, for your WeChat journeys. They may have all different workflows, have all different information. And so the customer, as a customer, asking the same question on different channels, they may get different responses. And so this is something that we want to solve with AI. And the last but not least is that it all sounds a lot of information. It sounds very complicated to get started. But my suggestions to you is like what I have done for the movie recommendation task. You do something simple first, right? You start small. You focus on a very niche area, and you prove that it works on a small area. And then you try to expand it into different areas. So for us, one of the simple ways is that maybe we just do pre-sales inquiry on WhatsApp first, maybe. That's maybe one of the large pain points for companies nowadays. So if we do it well, we can expand to pro-sales on WhatsApp. And we can do loyalty management on WhatsApp. We can do engagement and after-sales marketing on WhatsApp. And after that, we build all these journeys on WhatsApp. We can just copy the whole experience to WeChat, to Instagram, to website, to your mobile apps, or to your websites. And all would have all the same journeys on the same information. And the customer will expect the same responsive, meaningful conversation on all your touch points. And this would be a good way to start any NLP project. All right, guys. So I think that's it with my sharing. So if you would like to learn more about SetSell and what we do in using NLP in today's market, please keep in touch. And this is the QR code you can scan to contact me personally on my email and WhatsApp me on my phone. Thank you, guys.
Okay, I'm back. So thank you so much for Sunny presenting for us in this early morning. I think Sunny still haven't had his lunch yet. So thank you very much, Sunny. Okay, so let's move on to our Q&A sections, and we'll also have a networking sessions with all the online audiences here. So I've already saw some of the questions pop up already, but for me, myself, I have some questions to ask Sunny first. Talking about the trends of implementing NLPs, a lot of firms are now want to adopt this kind of technology. But this is quite a common case. They will ask, okay, how long does it take, like normally, to train an NLP model to solve my problems, or how long it takes time to actually return profit by using NLP technologies? So what kinds of any metrics to measure this kind of cycle for using NLP or ML technologies?
Yeah, that's a good question. So the first thing is that you have to determine your KPI on why you want to do an NLP project. This is the most important. What makes the business case for your company to build something like that, right? It can be either be a smarter AI or smarter AI to approach customer to buy goods, right? So this is a very easy way to measure effectiveness,
Yes.
or maybe it's a way to reduce your workload on your call centers. So there's a cost effectiveness of your part. So once you have the KPI, you can find what is the best solution out there for your problems. And actually, there are really many open source or packaged solution nowadays. For example, Google or Amazon, right? So offer a lot of NLP APIs that can be off the shelf used by companies to solve NLP problems, right? Classification problem, sentiment problem, intent extraction problem. But if you are looking for a package like an off-the-shelf solution for e-commerce, right? You can find companies like our company, and we can readily deploy a solution for you within a month or two, and you can see the results coming in really quickly. So my suggestion for you is that you first have to understand what your KPI is, try to measure it in a quantitative way. And then the second is determine what is the best approach for you to look for these kind of solutions.
Okay, so after the deployment, so usually how does it to further improve it after the deployment? So what measurements we have to, what solutions we have to keep, like keep adding data? Is it that simple to keep adding data to make it improve, or any other fine tunes for the whole model?
Yeah, so it also depends on what kind of NLP application you have. So for example, if you have a question answering application, like a chatbot or virtual assistant, it's really important that you use the data from your live chat agents to continuously train the AI counterparts, right? Think of the AI as one of your teammate in your live chat team, but this is just a machine, right? Maybe you handle a lot of inquiries with your human agent already. And you can use this data to feed back to the AI to see, okay, these are the new inquiries, these are the new way to handle them. And the AI can actually observe and learn from the human counterparts on how to improve. Right? So this is a really good way to get more data from your existing process and try to improve the model you have. And the second part is actually you can get the data from the users, right? So for example, like Google or YouTube, when you watch a video, YouTube may ask you, is it a good video?
Yeah.
Is it a meaningful search results for you? And basically people will give feedback. And these are very, very straightforward feedback. And they will use this as data to retrain their model to.
But I suddenly have an interesting question follow-up. Have you encountered like some firms, they're actually not framing the problem properly and they directly ask for, like some of the people out there may think, oh, this AI or this ML is a tremendous, very strong tool, it's powerful tool, but is there any use case that happens in ZSL that maybe some of the client doesn't even know what their problems are for their businesses, but they actually just ask for using this kind of implementation? So if you encounter such a case, how would you suggest him or her to further review on his business issues?
Yeah, so this is a very common problem we face. So that's why we have a sales consultant, sales consultant to help with the scoping of the project. A lot of the clients may first learn about the word AI or assistant. They think of Siri, right? They think of Google Assistant, and they say, "Oh, I want a Siri for my company." The same thing that Apple is building, right? But a lot of the time, this is not exactly what they want. First is that it's very expensive to build Siri. Second of all, even if you build a Siri for an application, how would people learn how to use it, right? And most of the time, it's actually much more deep down. They have a business problem to solve. Maybe it's as trivial as that email marketing is no longer effective, right? So they think, okay, how come my click rate is so low, my transaction rate is so low? And we found that, okay, actually you are broadcasting your same message to all your customers with the same content marketing, right? And that's why the people that engagement is not happy about your build something very similar with this, right? As I show, you can try to understand your customer more by using NLP. Okay, this guy is really more interested in sushi or omakase, right? and basically I can understand the preference. Instead of what, I can broadcast something very personalized to this user. And then build an experience based on that. For example, I can say, oh, by the way, I have 5 really good omakase restaurants in Zhangano, right? Would you like? And people may then ask, oh, how much is it? How can I book? And then you can use AI to build the experience from there. And so you have a problem at the very beginning is that you have a low click rate through your email marketing. And with AI, you improve your click rate. And then you use the AI to build the engagement further, to expand your scope of services by doing recommendations. Right? So that's a normally pretty interesting way forward.
Yeah, I think that's a very good example from Sun. Also mentioning the powerful not only on the automation, I think the personalization of the whole tools of this technology. Okay, let's check on the questions from our own audience. Okay, so if the vocabulary has more than one interpretations, like some kinds of jargons or there are cultural difference in meanings, is there a way to fix the bot's performance?
Yeah, so that's why the data mining is very important, right? So for all machine learning, it's garbage in, garbage out. Of course, models like BERT or like Spacey or different models have some kind of understanding built into the model, but cultural understanding is a totally different idea. So for example, BERT, although very well designed, it supports a lot of mainstream language. It would never support all the language and all the cultures in the world. So that's why we have to fine tune the model in order to be adaptive to the local context. Right? And that's why companies like ours exist, because we actually build model that is culturally aware. Right? For example, when we build bots for insurance company, when people say 入咗廠, right? It's actually meaning they probably want to do medical claims, right? So this kind of understanding, you have to mine it from different sources. One good source is forums, right? So you can mine your embeddings from forums like in Hong Kong, and you can understand different jargons, and you can understand different cultural differences on different works, given the context, right? In terms of interpretation, it's also an interesting problem because when I ask you questions like, can I file claims if I'm from mainland China, right? It may seem very straightforward questions, but this inquiry may actually prompt different response if you even ask different people inside the insurance company. So how to interpret the right impression is very tricky. But there is a few ways to mitigate this risk. So for example, if your model determined there are many different interpretations on inquiry, you can actually clarify with your users. And
asking more questions.
Asking for more information, asking for double confirmation. Oh, are you actually meaning that you bought your insurance using mainland Chinese ID? You want to file a medical claim over $10,000 at BBC? And if the user say yes, then you can correctly provide a response.
Like having a flow.
Yeah, exactly. So this is a way for the experience to be smoother and either provide, rather than providing a yes, no kind of answers.
Yes.
You clarify with the users. You try to identify or find out what the user is actually meaning.
Okay, so do you ever have data problems with sparsity? I think if so, what have you done to fix such problems?
We don't really have worked with sparsity a lot, so I can't really handle this fix reply this question.
Okay. Okay, so what factors determine the performance of parsing?
Okay, so for parsing is actually a problem with your pre-processing. So I think it's also very tricky to deal with the model when you have different layers of pre-processing. So it's really important that when you find the right model, you have, for example, like a part of speech tagging or when you have tokenization, all these are built within the same model concept. So for example, for parsing, it's quite difficult to build a separate model for parsing or for tokenization from your classification model that is different. So I would recommend you, if you encounter this kind of problem, you normally would find resources from open source community like BERT. They have already built into the pipelines on different pre-processing layer, like parsing, like embeddings, like the power of speech tagging and stuff like that. And you can use the model to fine-tune there. Of course, you can use benchmarking techniques that help you to benchmark different performance from parsing. But I would normally suggest you to see your performance or to benchmark your performance on the whole model rather than one part of pre-processing. Yeah.
So I have a question, Paul, again. So what do you think the future of this technology will keep moving on, like especially on a different chatbot or voice bot, like how far it can go to, or like how can it evolve to a more powerful technology in your perspective?
Yeah, so there are many, I think, three trends right now. So one trend is how well you can explain your model, right? So what we call the explainability of your machine learning. So right now, a lot of this NLP model is black box, right?
Yes.
As the user had asked, if you use BERT, you can't really pinpoint different accuracy of different layers. It's quite difficult. But I think going forward, there will be more tools for us to understand if I input A and the model classify this as a topic C, you can actually pinpoint where it goes wrong. Right? Okay, is it tokenization problem? Is it power of speech tagging problem? Or is it a problem with the segment tokenizing? So you can see different results from within the model and try to understand why it goes wrong. So I think this is a very interesting research area for us to really understand how this kind of deep learning model functions, or explain why it works like this in mechanical. And second part, I think we see NLP would go way more personalized, right? So it means that it would capture way more information for your context understanding. So for example, when you initiate a session with customers, you have a lot of surrounding area, right? When this user asks this question, on what platform does this user ask question, what this user is from, and what they have bought, what kind of customer tier they are belonging to, and if they have asked you this question before and stuff like that. And these all may affect your customer response, right? Yeah. Imagine this guy is like the most important customer you have, and they have already emailed you, and now he's calling you, right? So you really be, okay, this is
ranking
important.
Higher level.
Yeah, exactly. It's really important, and the way you respond is very may be different context of your understanding of the problem. Right? So the second part is a more contextual understanding of your inquiry. And the third part I see is more adaptation on NLP in the business world.
Do you think now is like mass adopt enough?
No,
especially not.
It's far from that, and I think part of the problem NLP is still at a stage that is beginning to mature. I'll put it this way, right? If you think of image recognition, it's a problem that is way more mature than NLP, right? If you take a picture nowadays, a lot of image recognition can correctly identify 90% of the object. But NLP, with the introduction of BERT, as I mentioned 3 years ago, it passed a lot of accuracy benchmarking compared to human in answering questions, understanding grammar and stuff like that. But some area like generating text or generating response is still not as sophisticated. Of course, there's model like GPT-3 from OpenAI, but unfortunately, that's not open source. Right? So I think going forward, you will see a lot more open source and more mature language model like BERT then you can just take it off the shelf and make very meaningful application out of it in a matter of 1 hour or 2 hours. Yeah, so that's what I see in the next 3 to 5 years.
Okay, so yeah, we still have 10 minutes left, so I will now enable the chat room functions. Okay, so if you still got any questions, you can still ask in the chat rooms, or if you want to get to know more about Sunny's, no matter his business or no matter you want to communicate or conversate with him, you can just type in the chat room here. So, okay. Sunny will answer you in these 10 minutes. Okay, West. Okay, grab your time.
Oh, okay. That's a good one.
Okay.
So the question is, how would you differentiate from your competitors, right? So the funny thing is that when we start our company 5 years ago, we have way more competitors, and now we have a few. And I think our competition is really good because NLP is such a huge project. Imagine how many mobile app developers in Hong Kong. There are over 100. Right?
Yes.
And how many NLP or chatbot providers? Maybe a handful. And going forward, I think messaging is actually going to replace majority of your mobile app experience. Yeah. And the most successful case in the world is WeChat. Right? With WeChat, you basically install 100 apps. Right? So going forward, we will have way more a company that will focus on NLP, will focus on building bots to handle various tasks. And for us, our strength is really to build bots that can achieve commercial success. The way we do it is first, we understand local market. Right? Our whole team is from Hong Kong. All our engineers are in Hong Kong that build language model that are for Hong Kong users. Right? And secondly, we have collected a pretty substantial amount of database. We handle over 100 million inquiries every year. And these data are actually feeding back to our machine learning to build a more accurate model over the time. So, and third, we have a huge amount of integration nowadays. So with different, for example, we have integration with Salesforce, Genesis, Avaya, various CRM or directory system. So that, as I said, if the chatbot has more context information, it will have more meaningful response. So that's why we have to expand our integration with all different systems.
Especially when now there's so many other automation tools they can integrate with each other.
Yeah. For example, one example is RPA, right? Robot automatic processing. So with RPA, you have basically different way to get data from different sources. But with the chatbot, you can understand what the user is asking, and it can actually ask the RPA to grab different stuff and build a report and then send it to the users. So I think it's an interesting use case to combine virtual assistant with RPA application.
Okay, so what is the biggest issue? Okay, I think that's you're asking the right person here. What's the biggest issue in doing NLP in Cantonese? So how to solve it?
There are two major hurdles in Cantonese NLP. The first is code mixing. Code mixing means that people normally mixing different languages together. So like doing gapsa, right? It's like you talk about Chinese sometimes and then you suddenly include English.
And also will they, I don't know the statement, like the 音調會影響, especially when Cantonese have.
Yeah. But that's the problem with the speech recognition. Right? So speech recognition would be another problem that Google or Apple has to face. Right? But when we talk about Cantonese inquiry, a lot of the people will have speech like doing like code mixing, and then you have a very huge amount of slangs. Yes. Imagine what is the slang for one word? Like the chong is like actually 醫院 stuff like that.
鏡粉.
Yeah, exactly. So new stuff like that. So you have continuously to look mine for these new words, and basically you can do it from two sources. So one is to do a data mining on open sources like forum, and second is that from all your channels, your engagement channels, you use this data back into your model, right? So this is the second part.
Okay, what is the difference? Okay, compare. I think that's similar. That's kind of similar.
Yeah.
Or do you?
No,
think you
it's
can
okay. It's a good question.
elaborate?
So the question is, what is the difference of running machine learning in Cantonese compared to that in English? It's pretty much all different except the classification part. So imagine your model have different layers, like you have pre-processing layer like tokenization, path switch tagging, you have segmentation of the works, position embeddings of the works. And then if you feed it into the model, and then you at the end you have a vector space, as I said, you find a similar vector space. I mean, finding similar space from the vector space is pretty much the same, right? But anything before that is different. It's totally different. So the way you process Cantonese is different because you have different slang, you have code mixing, so you have to handle it. And sometimes the way people say about topics is sort of different. So giving you an example is that when people use a chatbot in English, they normally type questions like, how can I apply for this job? In Cantonese, they will not do that. They will just put a keyword or something like this job, apply, or something. Yeah. How much? How much for this job? It's all different. The way people speak, like especially Hong Kong people speak, is so different compared to.
And also the logic thing.
Yeah, the logic thinking is also different. Like when you think of the culture of Hong Kong people compared to a British, the way they express themselves is different. So your language model has to actually cater for these kind of scenarios. And the way we have to do is to build different pre-processing layers to try to trickle or tackle these kind of nuances in the languages.
Okay, we will end like 2 minutes later. So if you still have any questions or you want to anything you want to inquiry to Upper Sunday, you can just type it here. We still got 2 minutes. Final questions or final inquiries, I think. If you also want to further inquiries, you can just email to info@haeba.org. We can refer those inquiries to Sunny, or if you need Sunny's contact, just say it in the chat room. We can still help you here. Okay. If there is no more questions, that's the end of part one's webinar. So thank you so much for Sunny joining us today. I think it's a quite informative part one, especially when covering so much different topics and different use cases in the part one webinar. So thank you so much for Sunny joining us. So we will now have a 10 minutes break. We'll back at 1:55. And for the next part, we will have Terrence from Banner Labs to share with us. So grab your time for a water break or a toilet break. See you later.
Thank you.
Thank you. Okay, thank you very much for all our audiences for waiting us for this 10 minutes break. So welcome back for today's webinar part 2. So in this section, we'll cover more about some of the real case sharing and some demo cases of how like product recommendation or different bot chat, how can it can be implemented into e-commerce or retail use cases. And speakers will also talk about data collection, construction, and cleaning some of this kind of process. What kind of process incurred in such ML loop or model. And also here we cover about some of the ethical issues that behind machine learning. So when we just have Sunny in the part 1 to talk about some of the chatbot function, but as text is a form of data, what about the human voice? Is the voice data, the biometric data of voice can be like further implement in this kind of technology. So our speakers today have a great specialist and focus on this kind of technology and field. And also we talk about the ethical issues arising from the machine learning, especially when we just talk about different biometric data incurs like the human voices or some regular behavior of different customers. As the AI sometimes, the crowd would say AI present 3 major areas of ethical concern for society, like the privacy of surveillance, the bias and discrimination, or is it perhaps like will causing different human judgment across different person? So let's have a specialist today, Terence, the Vice President of the business consulting from the Fennel Labs, to share with us on this topic. So thank you, Terence.
Thank you. Okay, thank you. Thank you very much for having me here today. So today we are going to talk about the language AI as well as the use cases and the ethical issues that we might come across in doing like machine learning implementations. Okay. So maybe I can just do a very brief introduction about company. Okay, Fennel Labs. We are a local startup. We have been in the business for around 6 years. So we basically, we start with building NLP technologies targeted for chatbot use cases. And then eventually find that maybe speech is more an intuitive way to interact with customers. So, and in the market, there are not too many solutions that could really fit well, in the Hong Kong market, considering, the languages that we speak and write. So it's quite unique because when we talk or when we write, we always mix with, Chinese or Cantonese with English, and sometimes we even write simplified Chinese in our text. So how to deal with this to, allow our customers to interact with the companies or the retail shops more easily in their own way. So we want to achieve that. So this is the reason why we set up the company. So we are a spin-off from University of Hong Kong. So we have our local R&D in Hong Kong and with 2 offices, one in Science Park, one in the Inno Center in Kowloon Tong. Okay, so basically our focus is to help different enterprise, commercial companies to overcome this kind of customer interactions issues and see if we can help them not only that to provide a better user experience, but also see if we can provide more business insight for them so that they could fine-tune their operations to improve the operation efficiencies. So basically our targeted market, okay, will be on different segments like banking industries, insurance, airlines, government, public sectors, retail, utility companies. Those who are heavily, engaged with customers, and then we want to know what people think, and then they would like to, engage this kind of technologies, okay, to help them to improve their operation or business. Okay, just to talk about basically what kind of AI technologies that we have built. I think in the previous sessions, Sunny has covered a lot about the NLP. So it's mainly used for chatbot, okay? But we also use this for other application in speech, which I'm going to talk about one by one in detail. So basically, AI solutions, or what we call the language AI, or sometimes people will say conversational AI. What kind of components that we have we need in order to facilitate this kind of application. So I'm going to just go through briefly about this kind of engines or solutions, and then we'll talk about the application, how it could apply to especially in the retail market, how we can make use of all these different technologies and solutions and build up some very useful use cases. Okay. So first of all, as I mentioned earlier, okay, the language in Hong Kong is complicated. Okay, people mainly can speak Cantonese, and people do mix English, okay, in their daily life. And of course, there are lots of expats or people who native language are speaking English. And then of course, we have people from mainland and then people who speak Mandarin as well. So in order to deal with this, okay, the traditional way how people deal with it is, okay, they will have different, what we call the language pack. Okay, one for Cantonese, one for English, and one for, let's say, Mandarin, so that they could recognize what people say, okay? But in reality, this is a bit tricky because if you want to have very decent user experience, then what if we can detect what customer actually say, or in between, they might switch the language, okay? If we can have a technology that can automatically detect what the customers say, instead of having them to select the language in advance, that will give them more superior user experience. Okay, this is what we call the auto language detection. It's something that, okay, we can offer, okay, especially for Hong Kong market, this is very critical. Okay, unlike in the US market, because mainly people speak English or Spanish, but nothing really mixed with the two languages in their conversations. Okay, and then of course, the other main piece in the technologies is speech recognition. Sometimes we call it ASR, automatic speech recognition. Okay, so, or sometimes we call it STT, speech to text. Basically, it's to transcribe speech into text so that you can do other subsequent process like NLP to understand the intent of the conversations. Okay, so this is a very critical piece. I'm going to talk a bit more detail. And then to identify who this person is or to verify who this person is, okay, actually, your voice is very unique. Okay, we can leverage what we call voice biometric technology. It can actually, based on your characteristics of your voice, usually it's more than 100 characteristics, we can determine whether you are the one whom you claim you are to authenticate yourself, which gives people a very intuitive way to authenticate, because considering that when you are talking to a customer service representative, and at the same time, your identity has been verified, and without the need for you to say, oh, pop up your token or receive your one-time password and tell the, the chatbot, okay, or your application, okay, what's the one-time password? Okay, you can just simply use your voice. When you speak, it can authenticate your identity already in single process, which is very user-friendly and secure. And I'll also talk about it, okay, a little bit. And then, of course, okay, why customers are engaging us? Okay, then we would need to rely on what we call the NLP, which Sunny has covered quite a lot in the previous session. So I will touch it a little bit on there in this area, okay, but mainly I will focus more on the speech side. So NLP, we have to understand the intention of the customer inquiry. We understand what they are talking about without knowing the need of mentioning specific keywords. It gives a more robust accuracy and more flexible way, and then we don't need to dictate the customer to follow specific instruction or keyword to tell us what exactly that they need or what their problems are, okay? And then, of course, what I've talked about is more from the input side from the users, but what about how to feedback to customers? Assuming that we are using, speech, as the input from the customer, it would be great if we can use speech as the output to play back the information to the customer as well. And so we think speech synthesis is also a good thing that we could incorporate into this kind of applications to make the experience more consistent. So speech synthesis, or sometimes also known as text-to-speech, TTS, is also something that we would talk about a little bit today. Okay, so that it can cover the whole customer journey. Okay, hopefully all this topic could help people, today's audience to understand more about what AI could do these days, and especially in Hong Kong market, how we can address all these issues and what are the use cases. So just to start with, here I illustrate a diagram about different use cases, and then I will deep dive into them one by one. But just to give everyone a holistic view about in terms of customer interaction or engagement, what are the different channels we will come across on a daily basis? Okay, so start from the left-hand side. Okay, we see the voice bots. okay, or the robots. So this is something that, okay, assuming that we would use voice to interact with customers. So you may consider that as a speech-enabled chatbot that can talk to, customers. So this could run on a telephone system. Okay, just like if you know about what an IVR is, interactive voice response, which is the traditional phone banking system that you use, you call the hotline and then press 1 for this and press 2 for that. This is the traditional, what we call the IVR application, interactive voice response. You, based on the keypad on your phone to select your options. But the bottleneck is that you have to listen to all these voice commands one by one and to navigate, and which is pretty tedious and people don't like it. You will always try to press 0 to reach out to live agent because you get sick and tired about this kind of interaction. Okay, voice bot is by leveraging the AI technologies on speech recognition as well as NLP to help to understand what the customer wants by just saying what they want or what the problems are. So this could be something that run on telephony platform. Okay, so you can think about this is a new generation of IVR, but with NLP and speech recognition on top. But sometimes it could also run in different form factors, just like a physical robot. Okay, because now you see lots of different robots in the market, like Timmy, Bryce. You see lots of this kind of robots in the market in the shopping mall. Okay, so we can also enable them to understand what the customer wants. Okay, just by consider that they are a moving concierge, moving around who can help your customers in the mall to answer questions, to give them directions or where the shops are. This is what we call the voice bot. Okay, use the voice to interact with the customers. Okay, through different kind of platforms. So in general, we call this voice bot. Okay, in voice bot could also consider into 2 major streams. One is inbound. That means the customer trigger the inquiry. Okay, so for example, in the customer service hotline perspective, if the customer call you, okay, call the company, this is what we call the inbound applications. So usually they will call the hotline, say support hotline, or call the hotline to make a reservation for the restaurant, or want to make a phone call to place an order. Okay, then this is what we call the inbound applications. But also we could also use voice bot to build what we call the outbound application. Let's say if a customer has make a reservation for a restaurant. Okay, you want to confirm whether the customer would come over on time. So you can leverage what we call an outbound voice bot to make reminder. Okay, by making phone call automatically at a specific time, which of course you can pre-program, and then it will remind the customers, okay, whether you are gonna show up on time today at 7 p.m. for a table of 4, let's say. And then the voice bot can help you to do all this without the need to engage a human to make all this kind of reservation or repeated work. So I'm going to have a demo on that later on. So this is what we call the outbound voice bot applications. And then we also, of course, the traditional chatbot, okay, that you can use text to interact with customer running on different platforms. It could be an app, it could be in WhatsApp, WeChat, you name it. So anything that is in text form, okay, chatbot. So I think you have a pretty good understanding after the previous session about what this is. And then text to speech. Okay, this is something that to synthesize text based on synthesize voice. Okay, based on its text inputs. So it could be dynamic information, and it could be used in many different ways. For example, in voice bots, okay, since the customer would say something out, okay, of course you want to play back some, information back to the customer with voice as well to give them a very consistent user experience. Then this is something that you can leverage text to speech. The benefits of having this is because you can use your voice and use the voice to play back some of the dynamic information without the need to have someone to pre-record the voice information. This is particularly useful when you are dealing with very dynamic content, okay, like the name, the address, kind of dynamic information. Then this would definitely help you, okay, to provide really dynamic or the real-time information in your interactions with customers. And this could also apply to different shops or branches. If you want to pay back some promotional message when people come over and visit your stores, okay, you can have the TTS to play back regular messages, okay, in the shop if you want. And then for those companies who have contact center, meaning that okay, they have a customer service hotline, to deal with the phone inquiries or email, live chat. Usually in this kind of scenario, many companies don't have a clue about the overall, landscape, about what people are calling or about what are the questions, any room to improve their operations. Usually they are only busy to, ask their staff, which is what we usually call the agents, customer service representative or agents, to answer the customers' inquiries. But other than that, they don't have a really, comprehensive overview about, how their companies are doing in terms of their services, their products, whether their customer really like their solutions or products or not, and if so, what are the reasons? So by introducing what we call the interaction in analytics, okay, we could process all the interactions between your staff and the customers, be it a phone call, live chat, email. We could process every single interaction and understand the intent, why they are contacting you and what are the issues, and how your staff answer those questions, whether there's any room to improve, the performance of the agent, or if there's any specific questions that your staff don't actually know how to respond. Okay, if we have a platform, to list all this out, and then you can definitely, based on this, to help you to improve your business. And this is also part of when the companies are talking about big data. Okay, interaction analytics is a very good way to provide this kind of analytics information to fill in the big data, missing piece as far as the customer interaction is concerned. Okay, so here I try to give everyone an overview about what kind of scenario or that this kind of interactions can take place. And from each of these components, I briefly list out all these building blocks that I mentioned in previous page, so that you get a high-level idea of what are the components that it might consist. Of course, there will be some more components in certain specific application here and there, but mostly, okay, these are all the building blocks, just to give everyone an overview. Okay. So let's get into the detail, okay, about this all these building blocks here. So let's talk about the language detection. Okay, so language detection is something that is quite tricky in terms of without the need to specific to specify the language that the customer is selected. Of course, you can think about in the website, you can always select the language at the landing page before you navigate. Same applies to other applications like chatbot. But I think up to this moment, I think most people are getting sick and tired about when you call up the hotline, the first thing that comes up in Hong Kong is to select a language. Let's say press 1 for Cantonese, press 2 for English, press 3 for Mandarin. Let's say this is something that we have come across in the past few decades, and then I think most of the customers are sick and tired about all this. Okay, this is the first thing. How can we improve that? And not only that, this is the language selection is something that always puzzle the customers. Another thing is we see that in many interactions with customers, maybe they would try to adopt to local culture. They would talk in Cantonese first. Okay, for example, I'm interested of buying this stuff, and then what kind of features does this phone can provide? Let's say, okay, and then they might speak in Cantonese first, but by the time they actually need to place an order to complete the transaction, they must switch back to their native language because they feel more comfortable. They try to avoid making mistakes, and then they switch back to their language, be it in English or in Mandarin. So it happens a lot. But if we can only understand a single language in the conversations, this is not something really good, because when you are doing different type of interactions like voice or analytics with the system, with the customer, you can only understand the first part of the conversation because it is a language that the system has been predefined. But what about the rest of the interaction, which is spoken in the other language? Then you don't understand. Okay, so this is always a challenge in Hong Kong. Okay, so consider, when's the last time that you speak in English and Mandarin, right? So this is something that we come across on a daily basis. So by introducing what we call the automatic language detection, so we can understand the customer's language without specifying it. This can apply to both text as well as voice recognition. So this is something that we hope we can help, the companies or enterprise to give a more superior user experience without the need of having them to specify the language, especially in some scenario, it would not happen. Consider the scenario like when you're having a meeting, okay, which involve people speaking Cantonese, English, and Mandarin. And in many occasions, people can understand other people's language, just that they don't feel like speak in that language, but they can understand. So in a meeting scenario, let's say you want to take a meeting minutes. Okay, what if the system can understand all these languages without specifying it? So I can transcribe all languages, okay, in one go without worrying when to switch to Cantonese and Mandarin or English. So this is how this technology can apply, okay, for our customer interactions, okay? So the one I mentioned is to determine, the language, but of course, the core piece is to transcribe, okay, the speech into text, okay, so that we understand, okay, subsequently, when we use NLP, we can understand what that means. But before that, we have to make sure, okay, the speech to text piece is there. It helps you to transcribe, speech into text. And the challenge in Hong Kong is very challenging in terms of, the language. Even when people speak Cantonese, they always mix with English. So we consider this is still as a Cantonese, just that it mixed with English word. So it's different than the use case I just mentioned about, automatic language detection, which people might, swap in complete English sentence or Mandarin. But in Cantonese, we always mix with different, English word. That's fine. Okay, we hope our engine, speech recognition, can also understand it. Okay, and the other challenge is that about the different accents. In Cantonese, there are lots of accent in Guangdong province. Okay, and for people who may speak that in different accents, or sometimes even when we look at some people when they speak in Cantonese, they will always have this kind of weird sound, like what we call the lang yam, right? So the pronunciation not necessarily be correct all the time, but how to deal with it, which is our daily business. So we cannot expect the customer, can speak, very rigid and, accurate Cantonese, because this is not user-friendly. So in order to overcome it, by leveraging machine learning-based speech recognition technologies, this can really help us to understand, what customers are saying before, okay, we can do other subsequent downstream processes like NLP or other process. So this is a very crucial piece when we are talking about interaction with customers. How to get a good speech-to-text engine is challenging, to be frank, and not too many companies, not only in Hong Kong, but also in global perspective, could they really provide a very decent, speech recognition engine for local market with the capabilities or consideration about all the challenges I've just mentioned. This is always a big question, and hopefully our company can help the enterprise and companies to overcome this. So, and the solutions that we could offer is something that it can run on cloud or even on premise, because some of the companies, they don't want the data to go to the cloud. They don't feel secure, or because of some local company security policies. So how to deploy that on premise? This is also something that we have to figure out how to downsize the system so that it could put on premise without worrying heavy investment to get all the equipment to run this kind of applications. Okay. And other reasons, okay, especially when we are talking about consumer markets or about the retail, we have to cover different kind of customers. Okay, maybe people at the younger generation, they are okay with the text, but for people like the elderly people or people with vision impaired, let's say, speech becomes the almost the only way they feel comfortable to interact with the customers. Because consider the fact that if you don't provide a comfortable way for them to interact with your companies, the chances are you might lose the business. Okay, because they will have less channels to contact you as the solution or product providers. And then you always want to engage your customers and provide as many channels as possible to make them feel comfortable to interact in their own way. So speech is definitely an advantage on this perspective. Okay. Then of course, NLP, something to help us to understand, okay, after the transcription of the speech, what does that actually mean? What's the intention of the customer? Okay, so this is something which is crucial, especially when we want to build the application, we want to respond to the customer inquiries. What do they actually mean? Okay, then we definitely need to rely on the NLP module to help us to understand and to extract all the relevant information or entities. Like, okay, for example, okay, when will be my mobile, contract ends? Okay, this is something that, okay, my intention is to renew the contract, or I'm looking for a new plan. Okay, so this kind of interactions, the customer may just want to state your own problem without stating exactly what they want in terms of the service, but the NLP can help you to understand the customer intent so that you can respond straight away in your applications. So this technology is crucial when we are building chatbot, voice bot, and actually in the interaction analytics as well, which I will go into detail. And then text-to-speech, as I mentioned earlier, is to, based on text input, you can synthesize it into speech and play back to customers. Okay. The good thing about this is you don't no longer need to, hire a voice talent to record, the voice prompts. Remember, okay, when I talk about this interactive voice response platform that runs on the telephone hotline system. So what they need to do in the past is that they have to hire a professional voice talent to record all those voice prompts, which are very costly. And in many occasions, okay, the marketing team guys, okay, they like changing, the content before, your application go live. And then if that happens, there's no way that you can, ask the voice talent, okay, can you come over tonight to record it? Because I'm gonna roll this out tomorrow morning. This will never happen. And even it does, you can, engage the voice talent, you have to pay extra for the voice talent, which is making the operation costs, very high. So we are trying to find ways to, overcome this by introducing, text-to-speech. And it's not something new, to be frank. This has been in the market for over 20 years. Okay, just that in the old days, the TTS quality is very robotic, it's very machine-like, and then people don't like it. And many companies don't like it because it will give a really bad image to the customer. Okay, your company is trying to cut costs and then you have a robot to solve me. But I'm going to show you some demo in Cantonese and see how good technology has advanced over the years with machine learning. Okay. And to add on that, the technology nowadays also allow what we call a custom voice. That means you can build your own voice. Okay, by, let's say I invite, someone is a celebrity to come over, okay, to record some voices, and then we use machine learning to train the system so that in the future, when we use the TTS to play back the voice, okay, the system can mimic that person's voice, okay, and this can, cope with the company's, marketing strategies and image, so that we have a, same celebrity not only show on the TV, but now we also have the same person to greet you in the voice bot applications, okay. So I'm going to show you some custom voice demo as well, okay. And this speaker verification is a relatively new piece in terms of among all the speech technologies. Okay, it's to, by leveraging a voice to authenticate, someone. Consider that, okay, voice bot is going to be, getting more popular and popular. Okay, the chances are not only that the people will call up, the application just to do some general inquiry, and in many occasions, they would do transactions like, okay, for banking, they would do fund transfer, they would buy stock, okay, they would buy structured products. For retail, they would buy, different consumer goods, okay. But if we can leverage, the voice as a second factor authentication so that we can make the interactions more intuitive and secure. Okay, I'm gonna do some demo, okay, show some demo later on as well on this aspect, okay. So in terms of the deployment, okay, of different applications that I briefly mentioned, based on our experience, many customers will think, okay, we just start off with chatbot and voice bot first, and then we would do other things, like interaction analytics later on, okay, because they think doing chatbot and voice bot first is easier, it's less, it's more lightweight. But in reality is that many business users, what they think are important in the chatbot or voice bot application are not necessarily correct in terms of, how likely the customers are going to ask those questions. Just that, oh, they know the companies have this kind of services and product. They would like to wrap all this up and put them into the chatbot and voice bot. But in terms of the priority and what is the, the level of detail of this application, actually, they don't have any clue. Okay. And then what we suggest, this is our recommendation in general, if the customers could afford, we would usually suggest them to do the interaction analytics first. That means we first want to understand why the customers contact, our customer service representative, to understand what are the hot topics that they raised and what are the issues and what are the things that we don't or we can't, respond properly by human. Okay, first, then we know, okay, this could be something that we have to pay attention. Eventually, when we are gonna, implement something like that to automate in the voice bot and chatbot. But before understand, having a holistic view about how customers interact with the companies, it's very difficult for you to design an effective chatbot or voice bot application. So usually, as you can see from this ladder diagram, so we will recommend, if possible, we will recommend customers to first, do an interaction analytics to understand, okay, about how the business is doing. What are the frequently asked questions first? Then you can, based on this fact, okay, to design your chatbot and voice bot applications so that you will have a more effective, application design, and then actually it can serve the purpose. Okay. Otherwise, everything is just, out from the business user's head. They think this is, something that it will happen, but in reality, okay, it may not be true. I will have some real-life sample very soon to talk about it. Okay, and then of course you can build more application on top, like the voice biometric to authenticate customers. This could be always something that you can build in second phase or third phase, as well as what we call the agent assist. So consider that you are running a contact center with lots of agents. So the problems are the turnover rate of this kind of customer service representative are really high. Okay, and usually when you are on board a new staff, the training cycle is very short. Usually you will only spend 1 or 2 weeks to train your staff, and then they will start to answer customers' inquiries. Okay, but in many occasions, those answers might not be very precise or might not actually help the customers because they lack of training. So by leveraging NLP, speech, and other components by the customer, like the knowledge base, what we could actually do is to do something like real-time speech to text, and then we send it to NLP to understand what the customer said, and then look up the knowledge base, find the most appropriate answer, and then show it to the agent's desktop, so that this could help the agents to answer their customer inquiries in real time. So I know this is more advanced use cases, but this is how we pave the customer interaction or customer care applications. So from the bottom, understand the customer's inquiry first. What is the breakdown of the inquiry types? Then the build automation application, as well as providing assistance to your staff to help your customers. This could be something that we would recommend when you're building applications to help your customers. Okay. So by following these steps, so let me talk about the speech analytics. So what it could do is to help you to understand, why customers are calling. Okay, so this is a comparison between the traditional way and what the interaction analytics AI platform can help you. So first of all, on the top, so it talks about how nowadays the contact center would do the analytics on their own. So usually what they do is they manually pick the interaction between the customers and then have the quality assurance staff to see how the agent or customer responds. And then they would know, okay, how to improve their business. But usually that will only take up maybe 1 to 5%, no more than 5% among all the interactions. That means 95% of the interactions are leaving behind and no one knows what's happening until the customers complain. Then you know something happened. Okay, but by using interaction analytics, all the customer interaction will be scanned by the AI platform automatically. You can configure different business rules, what you want to scan, what you want to detect. Is there any potential risk among all these interactions, you want to raise red flag if that actually happens before it's, something until someone file a complaint or someone posts it on Facebook, Definitely something that we want to talk about is the AI platform can help you to cover or to scan all these interactions. And then not only that, okay, it takes a long time for human being to listen to all this phone conversation before they know what actually happened. It's very tedious and time consuming. But by leveraging the AI system, by using the speech recognition, by using the NLP, we understand why the people are contacting you. What are the questions? Okay, will help you to classify the nature of the questions so that okay, this one is about the complaint, this one is about the product feature, this is about the renewal of the contract. So specifically what happened and what's the proportion of different kind of inquiries, so that how to allocate your resources appropriately based on the breakdown of the statistics of this kind of different types of interactions. And then human being usually, okay, they would, do the scoring for the quality assurance, but usually that would be some bias among all this kind of scoring because, human being, it's hard to, ensure that the performance is consistent. While if it is, conducted by AI platform, everything is very consistent and give a more fair, assessment of the staff performance or, if there's anything missing, then the AI system can always detect. While human being, sometimes it's hard to judge. So in terms of the use cases, okay, mostly for the interaction analytics, most people would think, first of all, they would want to know why customers are calling, so they can classify the natures of this interaction, so why they're calling. But also this can also help you to do more than that. For example, if you are in the in a very competitive business. Okay, customer churn is always a big topic because onboarding a new customer is usually more costly than keeping a customer. So customer retention is much cheaper than onboarding a new customer. So customer churn, meaning that, okay, the chances that the customer will leave your company, not using your service or products, becomes very crucial. So if in any case that we can detect such churn or potential churn, and then we can alert your company, okay, you have to take action before the customer leave your company. Okay, then you can save your cost by onboarding a new customer to replace this churn customer, right? So this becomes a really important objective of using this kind of interaction analytics by many companies and enterprise nowadays, because this can actually grow your business, because you can keep your customers here. Now, of course, you can also identify different sales opportunities. Why I'm saying about this is, there are lots of people doing telemarketing calls, making cold calls, to sell you something. Okay, but the chances are, some people are doing better jobs than others. That means they could sell more than others. But how can you improve that in your whole team to make sure everyone can sell the product and services to your customers? You don't know what are the tricks, right? In the old days, okay, you only know that maybe Tim is doing a good thing. He could sell everything, but Terence is doing a bad job to sell stuff. But how can you actually improve that? Or what are the reasons? And this kind of interaction analytic platform can help you to narrow down the reasons why some people are performing better than the other, so that you can learn from this, and then you can provide more precise training to your staff to improve their selling technique or operations, stuff. And this is also why many people are considering using interaction analytics to understand how they help their customers or how their staff are doing. And of course, if your business has any compliance, or anything that you want to monitor in terms of the company policy or compliance things that you want to monitor, make sure everything, your staff is doing are following all these rules and policies. Then this system can definitely help you. For example, when you are selling stuff, make sure the staff are not, making any, committing any commitment that your company's product or service do not offer. This is something very risky because they will file complaint to you afterwards. But how can you ensure such kind of overcommitment or compliance breaching issues don't happen? Or when did it happen? If it happened, I want to take a proper measure to address it right away. And this kind of issues can be addressed by this analytics platform because it scans through all these interactions. And by building different rules, leveraging NLP, we can detect all this kind of potential risk and raise the alert to the supervisor or manager so that they can follow up the issues when they actually happen. Okay. So let me take you a real story about a use case that we have a telco in Hong Kong. Okay, so it's about the churn customers. So what happened is that when you are trying to, how you can keep a customer staying with your company, especially in a telco, usually, okay, the people will leave when the contract is about to end, or your network is really bad, or service is very bad, and then you decide to churn and change to other mobile operator. And then in order to recover these potential churn customers, so what we help them to do is to build an AI model that could detect different patterns of customer showing churn signal. This could be based on the context. This could be based on the sentiment, the emotion of the conversations. And then we can build a model so that we can filter out all these potential calls. And then we will hand over this list, to the telco saying, okay, these are the potential, churn customers from yesterday. Okay, and then we will hang out this list to the retention team. Okay, so that the retention people can, based on other metadata, for them to decide whether they should call up this customer and offer them a retention program. For example, if the customer's contract is about to end within 2 months, definitely I will call up the customer because their contract is about to end. But if the customer still have 1.5 years before it actually ends, the likelihood of this customer to churn would be less likely because the customer is still bound by this contract for another 1.5 years. So the likelihood is not that big. And then they could make the priority and decision, whom and when they should offer this retention program. Make it more effective rather than in the old days. Okay, they just come up with a list and then they make make the call to the customer when they actually tell the customer, tell the telco, I'm going to churn, please terminate my service. That would be too late. The chances that you can rescue this kind of customer would be too late. By using the interaction analytics, we can know before it actually happened. So the chances of keeping the customers in the companies would be much higher. Okay. So they keep doing this exercise after we help them to build the AI model to detect the churn customers, and then they keep doing this exercise on monthly basis. And then the other thing is about something is quite interesting. So it's back to the story I mentioned about the business users. They always think that they know everything, from inside out, but in reality, that's not really the case. So this happened when the 5G actually launched in Hong Kong, and then the telco operators always think, oh, the customers concerned the most is about the coverage, the price, that's all they concern the most. So when they are preparing their package or the tariff plan, so these are what they focus the most. But when they actually roll out the service, actually, of course, these are also one of the top questions that the customer asks. But they didn't realize, in fact, lots of customers also ask whether you have a family plan. That okay, the 5G plan can cover several members in your family. Do you have such a plan? But in reality, the telco operator doesn't have that by the time they roll out the 5G service. So it's lucky that we have our interaction analytics platform already running, deployed in the system, so that they could spot this kind of inquiry after the service is launched, so that the marketing team can take proper measure to address this offer right away, so that they could consider, okay, I should really prepare a family plan for my customers. Okay, so the story learned is that the business users are not always right. They might be partially right on something, but that could be something that they overlook until we have the real interactions from the customer. Then we know what we need to fix. And that's also the reason why I said, if possible, we usually recommend customers to do the analytics first, understand the customer's intentions before we actually build the voice bot and chatbot. Otherwise, you might have some missing pieces in your application, and then you have to do it in your second round of the revision or the enhancement of the application. Okay, and then I will talk about okay, after we talk about the interaction analytics to give everyone an overview of why we think this is important for, for business or consumer market, then I would talk about the voice bot applications. So voice bot is not really new, okay, to, to say in North American market. They have had the, the first generation voice bot for more than a decade, what we call the grammar-based voice recognition. That means you have to define specific keyword that it can recognize it. But back in the old days, they don't support NLP. So everything is based on keyword. And then you have to state all these keyword as grammar, which is also known as entity from, from the NLP perspective. So you have to define all these keyword one by one before you can actually, use the voice bot. And it's still doing the job. It helps to improve the automation. Okay, but it's not as good as what the current or latest voice bot could achieve by leveraging the NLP, because it's more powerful and more robust. Okay, and to start with, usually we would recommend customers to, or enterprise companies to start with something like the outbound use cases first, because this can be much easier for you to work out an ROI, okay, for your, for your manager to prove that it has value. Because at the end of the day, many, companies think about voice bot is to, reduce the operation cost. And how can they do it? Okay, of course you can do a very complicated, inbound application, which I'm going to talk about later on. But the thing is more costly. And in order to test the water, they want to start something small. And outbound voice bot is usually something that we would recommend. So you can think about this as a very simple application by leveraging the voice bot to make phone calls to, your customer. If let's say they have made an appointment earlier, then you want to remind them, okay, you have an appointment this afternoon or this evening. Okay, would you come on time? Or if you make a, reservation to say doctor, okay, you can remind him. Okay, this kind of application is straightforward and easy to build, while it's also very helpful in order to reduce the human resources. So there are a bunch of different applications as I list here. Okay, maybe let's jump into some voice demo here to show you what a voice bot outbound application can actually do. Okay, so let's listen to this one for a restaurant booking scene. And this scenario, because there are several scenarios, this one is the person actually confirms the booking.
你好，呢度係有光餐廳打嚟，請問係咪陳先生？
咩事？
陳先生你好，之前你喺我哋餐廳訂咗3月25號夜晚8點鐘2位，而家想同你確認一下，到時你會
冇問題啊。
你好，呢度係有光餐廳打嚟，請問係咪陳先生？
咩事？
你好，呢度係有光餐廳打嚟，請問係咪陳先生？
咩事？
陳先生你好，之前你喺我哋餐廳訂咗3月25號夜晚8點鐘2位，而家想同你確認一下，到時你會準時出席。
冇問題啊。
好嘅，多謝你嘅確認，到時見，拜拜。
OK， 咁呢個就係第一個 scenario 啦，即係如果 voice bot 嘅話，我可以 confirm 客人嘅一啲嘅即係個 booking 啦。咁另外我哋仲可以睇到就係話另外 OK， 咁 what if 如果個客人就係話想取消嘅話，咁個 user experience 會點樣咧？
你好，呢度係有光餐廳打嚟，請問係咪陳先生？
邊位？
陳先生你好，之前你喺我哋餐廳訂咗3月25號夜晚8點鐘2位，而家想同你確認一下，到時你會準時出席。
啊，係喎，唔記得咗。
想同你確認一下，到時你會準時過嚟。
冇問題啊。
好嘅，多謝你嘅確認，到時見，拜拜。
咁呢度大家可以聽到個 scenario 啦，就係話個顧客唔記得咗嘅，咁我哋都可以設計到好多啲唔同嘅互動嘅 logic 啦，去處理翻個客人嘅呢啲咁嘅 scenario。咁變咗就話呢啲咁嘅 tedious 嘅嘢就唔需要話揾個同事定時定候咧去打電話去提翻個客人啦。咁我哋可以 set 翻啲 schedule 啦，跟翻住我哋嘅 database，咁就可以 make 翻啲 outbound call 去同客人 confirm 啦。咁除咗啲特別嘅 occasion 或者特別 scenario， 我哋先要揾一個真人去 serve 佢，咁就可以大大減省咗即係個人力啦。咁如果講翻 inbound 嘅話咧，咁就會複雜少少嘅，即係話如果有時有啲企業，因為佢好多產品服務，咁除咗我主動打電話去做啲 reminder 嘅應用咧，咁好多時候可能就會做翻啲我哋叫 inbound 啦，即係好似即係傳統嗰啲所謂 hotline。咁因為有啲時候，尤其是就係話on the road， 你可能上網唔係咁方便，或者打個 app 都唔係咁就手，或者啲老人家。咁如果我哋可以做到一個 inbound 嘅voice bot， 就可以俾個客人咧就即係打電話入嚟做查詢啦。咁傳統嘅就係頭先我講啦，即係嗰啲我哋叫做傳統 IVR 啦，靠撳掣啦，然後去 navigate 嘅 application， 其實佢係一個 tree 咁嘅 diagram 嘅一個 logic 嚟嘅。咁但係我哋如果用咗 speech 嘅好處就係我可以咧 narrow down 咗成個 user experience， 可以變咗係 flatten 咗頭先講個菜單啦。咁變咗個客人可以就話歡迎致電乜乜乜公司，我有咩幫到你 ？Instead of 我叫佢逐層咁去撳掣啦，咁佢就慳咗好多嘅時間。咁個 user experience 咧好咗之餘咧，咁佢sorry for that. Sorry to change back to the trend. Okay, maybe just let me go back to this previous screen. So I'm talking about the applications for the traditional what we call the IVR application. It used to be, level what we call the tier level or tree diagram architecture. That means that you have to follow the instructions and listen to the prompt one by one, and then you just follow the instruction, press 1 for this and press 2 for that. This is very tedious, and usually you will end up by trying to figure out where's the 0 button so that you can reach out to a live agent. But then, okay, by leveraging voice bots, it has eliminate the need of pressing buttons, because you can let the customer to say exactly what they want by using their speech. So it can what we call the flattened, the manual. Then you can just say, okay, for example, if I call a company, the company can say, can you briefly tell me what you are looking for or what you want, or how I can help you? And then we can understand what the customer's intention and then jump directly to that spot without the need to navigate to different levels. Okay, so maybe let me show you a video to illustrate what all this can do by putting all this kind of NLP and speech together. Okay, this is an example not for retail, but it's more for a banking application, but you can give you a more a better understanding about what we can do by using the voice bot technology nowadays.
你好，歡迎致電有光銀行，我係 Fanny， 請問有咩可以幫到你啊？
我想查詢匯率嘅。
好嘅，請問想查詢邊隻貨幣呢？
而家加幣對港紙幾錢啊？
加拿大元對港元嘅匯率係6.2。請問仲有乜嘢可以幫到你？
我想查下 account balance。
冇問題。為咗保障客戶，而家會同你核對少少個人資料。請提供你嘅身份證號碼。
K1357246括弧0。
啱嘅，請提供你嘅聯絡電話號碼。
97538642。
請問你嘅信用卡係用乜嘢方法付款嘅呢？
自動轉帳嘅。
啱嘅，請問你想查詢邊個戶口啊？
儲蓄戶口啊？
睇翻記錄，你嘅儲蓄戶口結餘為32,690蚊。請問仲有乜嘢可以幫到你？
咁支票戶口呢？
冇問題。睇翻記錄，你嘅支票戶口結餘為463蚊。請問仲有
我想由
乜嘢可以
saving account 轉5000蚊去支票戶口。
好嘅，你想由儲蓄戶口轉5000蚊去支票戶口，請確認。
哦，都係唔好啦，幫我轉夠8000蚊啦。
冇問題。你想由儲蓄戶口轉8000蚊去支票戶口，請確認。請確認資料正確嗎？
確認。
好嘅，已經成功幫你轉帳，參考編號為1357248。
唔該晒。
唔好客氣。請問仲有乜嘢可以幫到你？
冇啦。
多謝使用我哋嘅服務，拜拜。
Okay, hopefully this can give everyone a better understanding, what voice bot can achieve nowadays. You can see that it has a mix of many different technologies and technique to give a really good user experience. So this is something that I think we have developed over the last few years, and based on our intensive experience in customer interactions. Now, the key is that not only that you need to understand what the customer business requirements are, but we also have to understand customer experience and how you can create an application that is intuitive yet you can support experienced user, that you make sure your navigation or instructions are not tedious, while for those newbies or for the first comer, for those who are not familiar with the application, you can provide sufficient guidance for them. But also from this demo, you can also see another feature. I'm not sure whether you are aware of, is when we are trying to authenticate a customer, we ask them a few questions, right, during these interactions. So it has actually leveraged what we call the speaker verification. So on one hand, we are trying to use speech recognition to compare what the customer said, which is the answer, whether it matched with what we have stored in the database. But also at the same time, the characteristics of his voice is used to authenticate against his voice print. Voice print means the characteristic of his voice that has been enrolled in the system before. That is, actually this person. Now we, leverage all these utterances that he spoke in this voice bot to authenticate his identity. And he doesn't have to do anything extra. And then we can do what we call the second factor authentication, which is the voice biometrics. So hopefully this can give everyone, an overview about, how advanced, the speech voice bot can do nowadays, and, and especially in Cantonese, what we can do. And then next, I'm going to cover, a little bit about the chatbot, which I think many people have already got a really good understanding about what it can offer. It runs on different platforms, multi-modalities, different channels. And to add on that, I think not only that we have built our own NLP, which can understand the intent, but also by leveraging the speech input as an option, just when the customer are not having enough time to do text input, they could use speech. So here I give you some use cases that we have done before, doing some online shopping, food ordering, and support, and loyalty programs for some of the airlines. These are some of the user cases we can do. And let's listen to one of the voice-enabled chatbot demo here.
最近有啲乜嘢優惠？我想買香水。我想買 Coach。
So in this demo, okay, we have illustrate how you can use voice or text input, whatever the customer feel comfortable to interact with the chatbot. So in this case, for example, if I want to, buy the item, I can just say it out instead of typing. But if let's say I don't feel comfortable to say out my membership number, I can just type it. And then of course the chatbot can based on, my membership number and then the tier of my membership or the loyalty program, what kind of member type I am, and then I can give different kind of discount. This kind of interactions is something that we could offer in terms of chatbot. So how you can advance from the traditional text-based chatbot to voice-enabled chatbot to give better user experience, to use the application. Hopefully this can, improve the operation as well as the adoption rate. Okay, next I'm going to cover about the text-to-speech. So as I've mentioned about the use cases, so it's used to based on input text, and then we can play back, the voice accordingly. And just to demo this, the most important thing is about the quality. I think most people have listened to it. So especially for those people who have to, play around with, Apple Siri, Google Home, Alexa, then you know what these are. You have come across lots of this. But how advanced nowadays in terms of Cantonese? So let's listen to some of the samples here.
大家都知道，廣東話係一個非常之難學嘅語言，因為佢有好多唔同嘅音調。大家都知道，廣東話係一個非常。
Okay, so let's listen to one of the sample here.
大家都知道，廣東話係一個非常之難學嘅語言，因為佢有好多唔同嘅音調。
So here you can hear this is the default pitch of a TTS voice in Cantonese. And then we can also change the pitch.
大家都知道，廣東話係一個非常之難學嘅語言，因為佢有好多唔同嘅音調。
So you can hear the intonation is a bit different. And then we also have different voices, so you can hear the same, content but different.
大家都知道，廣東話係一個非常之難學嘅語言，因為佢有好多唔同嘅音調。
And also different pitch.
大家都知道，廣東話係一個非常之難學嘅語言，因為佢有好多唔同嘅音調。
So it's very natural. Consider Cantonese is a very challenging question because it has so many tones. So we can see, how the machine learning based TTS has become nowadays. And to show more challenging scenario is the mixed language scenario. Okay, let's see how it performs when it's mixed Cantonese with English, how it sounds like.
我去咗同 partner 開會，晏啲我先 send 個 proposal 俾你。
Okay. One more sample here.
我哋已經收到你份 claim application refund 嗰度可能會有少少 delay。
Right. So you get a good feeling about how TTS sounds like now. Okay, and let's move to the next one, which I think is a very interesting one because I'm gonna do to show you a custom voice, which is my voice. I think everyone has, listened to me talking for over an hour. So you're familiar with my voice and how it sounds like. Here is a game that I want to play with you. Okay. So among these samples here, okay, some of these are recorded by myself. Some are generated by the system. So either A or B, okay, in different sequence. So when you listen to the order and to these samples, okay, you can mark down, see which one you think is the TTS, which one is the real voice, and then I'll tell you the answer afterwards. So first one here.
終於輪到我啦，我就話我係真人，你哋信唔信？
And then the other one.
終於輪到我啦，我就話我係真人，你哋信唔信？
So among these two samples, one is my real voice, one is TTS. Okay, and let's listen to another sample.
覺唔覺得今日我有啲乜嘢唔同？
Okay.
覺唔覺得今日我有啲乜嘢唔同？
The third one.
有時間記得 call 我飲嘢，電話93681018。有時間記得 call 我飲嘢，電話93681018。
And then the fourth one.
下一個環節就係急口令，你估我有得唔得？下一個環節係急口令，你估我又得唔得？
Okay. I'm not sure how many find this is quite hard to distinguish? At least my wife cannot tell. She cannot get all the answers right, at least. And then also just show you, okay, the answer for this one.
我想同大家玩個遊戲，大家估下邊一個先係真人，邊一個係 TTS。
Okay, so the one in circle, are the TTS ones. Okay, so just to give everyone a understanding about how TTS advanced, especially for Cantonese, how it goes now. Okay, and then well, because of the we are running out of time, because I still want to spare some time for Q&A. Because speaker verification, we have already showed that in the previous demo when we showed the voice bot application, so you have a high-level understanding about what this is. Okay, so I'm not gonna touch too much about it for now. And then I want to save the last 5 minutes to talk about the ethical issues for machine learning, which I think lots of people may have some question about this. This is a statement that I've shown you from the Alan Turing Institute about the ethical things that we have to consider and what are the directions we need to consider when we are building machine learning, AI. Okay. So this is something that we always come across, okay, and not only that it's an illegal issue, but it's also an ethical issue that we want to make sure that what we are offering is on one hand we can help our customers, to improve the operation efficiency of the business, but at the same time we have to make sure that we don't create extra troubles to the companies. So these are usually what we always come across, or we have to ask ourselves whether what we are doing would eventually, get into some of these issues, or how we should, avoid all this. So the three major, things that we want to always avoid is the intentional harm. We don't want to provide anything that could harm our customers. Okay, so just to share my personal experience, especially in the chatbot space. Okay, many people or many customers or business users ask, can you do supervised learning? Okay, for your chatbot? Of course, technically we could do it. We could do unsupervised learning, but we recommend supervised learning somehow. The reason is, if you have heard about a chatbot from a very well-known international brand a few years ago, okay, they have launched a chatbot in China, and then they allow different people to provide training data to the chatbot, and within a week, okay, that chatbot has turned into a Nazi. Okay, and then they took down the chatbot and then fixed it and tried to bring up another unsupervised chatbot again. But within a week again, okay, the chatbot has turned bad because there's no control about how the training data as well as the response, and the chatbot learn everything, and it's less likely that you can, it's not a rule-based application. You cannot say, I remove this line and then it can, respond to the question properly. It's not likely the case. So when we are doing this kind of, application, especially NLP, technically we can do unsupervised learning, okay, but we usually will use it in different area, like intent clustering. We can help, use this kind of technology, unsupervised learning, to group similar intention, but in terms of the proofread, the actual response, we still want the human being to do the last judgment before it actually goes live. Okay, and of course, we don't want to use the technology to do different kind of surveillance. Of course, this is something that violates, the rights of people, right? So we always try to avoid that. We are trying to bring convenience to people, but we are not trying to step into their personal life, right? And then unfair outcomes, we don't want to discriminate people. Okay, we don't want to create bias, so that we make sure that when we are doing, not only in our response, when we are doing data collection, subject to the use cases, of course, then we try to, eliminate, okay, we want to bias certain group or certain race of people. Okay, we try to get the balance. We don't want to bias on certain particular, characteristics of the data that we are collecting, okay? And then, of course, when we are building applications, then we have to think a lot about, okay, what if something goes wrong, how we can recover them? And then is it possible to recover, or how can we tell something's go wrong? Chatbot, I think, is more easy to control because all the response and answers something that you can predefine in advance, unlike other machine learning applications. So I think, chatbot, voice bot are more, under control. But of course, there are some other machine learning applications that would be something that, in terms of the response or interaction with customer, that would be a bit harder to predict. But again, this is something that we always try to avoid. And then we need to have a framework to detect all these issues. And if so, how we can actually, provide proper measure. Say if we need to retrain the model all over again, okay, so that it can relearn instead of stepping into the issues. And then another thing is, especially when we doing data collection for chatbot or voice bot, okay, we need lots of data, customer interaction data. So how we can standardize the data, make sure that the customer data are not, collected during the exercise. So what we usually recommend is that we will provide some tools to sanitize customer data so that all the training data won't include any PR, personal information in there, because those would be useless for us anyway. So we will first clean up all the data before we always use it to train the model. And then there will be other specific ethical issue in speech. For example, the custom TTS scenario I just talked about. So we need to make sure that if we want to train a custom voice, we have to get a consent from the voice standard. Okay, I'm going to use your voice, to build this model, and the specific use case or specific companies only they will use it at their good hand. Okay, but we are not going to use it for other personal or other things that outside of the contract. That kind of thing is something that we have to make sure that we have laid out all these rules and compliance or consents with all these data providers before we can actually use them to train our models. Okay, so just something that I want to wrap up today with the ethical best practice that we have been deployed and used. Okay, so basically this is my presentation for today.
Okay, thank you very much for Terence presenting for us. Okay, I think overall is very fruitful content. So Terence especially have to spend a lot of time on his content, and I think we have like 7 minutes to 10 minutes for our Q&A, but I think the fruitful content already sums up many of your questions already. Okay, let's check on the Q&A part.
Sure.
Okay, we have 3 questions here. Okay, so question from Serena. Would that be even better to set expectation at the beginning of outbound call that the confirmation is from a robot?
It depends. Yes, usually how we greet the customer to set their expectation is, okay, this is your virtual assistant, blah 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 blah. This is calling regarding about your appointment booking. Okay, this could set the expectation, because this is a very good question, because there are scenarios that people might not feel comfortable when they talk with a bot. Okay, if we can inform that in advance, that would be better, because it could avoid some of the argument at a later stage. So usually we are not trying to, even though it sounds very natural like human being, but in most of the applications that we built, we would name ourselves. Okay, something like, okay, this is your virtual agent Terence, or this is your virtual agent Mary, something like that. So that set the expectation first, and then they know, okay, sometimes they're more comfortable actually to talk with a bot than a human being, especially when some people might have concern about disclosing the personal information, but if they know this is a bot, okay, sometimes they're more willing to chat with you. So this is a very good question, and yes, we do set the expectation in advance.
Yeah, I think especially when the bot sounds so naturally now, correct. I think it's basically escalating the customer experience when, especially doing the phone calls, right. Even though he or she may feel comfortable to expose more of himself to a bot, but also at the same time he can chat to a human, pretend he's chatting.
Correct.
Okay. So is spam or meaningless comments from the customers in the feedback form fatal to machine learning accuracy?
Okay, so it depends how you handle it, because for us, okay, so maybe I can talk about how we handle that. So we have what we call an intent cluster mechanism. So what it does is based on customer inquiries, of course. Okay, for some of the, if this is what we call in-scope inquiries, then we can recognize it. Or if it fall below the threshold, our intent customer can still group this. For example, this is an inquiry about iPhone. Okay, someone want to buy an iPhone. Okay, we will group that, one by one. And for those which are out of scope, we will still try to see if we can map, with one of the closest intent. Okay, if not, okay, it could be a new topic. But before actually the system would actually learn, okay, the update the model for the new training data. So as what I mentioned earlier, so we would still prefer to have the business user or end user to make the final approval based on the data. So we have already helped them to group all these different kind of inquiries based on the system's best understanding. Okay, these are a bunch of inquiries about iPhone. Okay, these are a bunch of inquiries about Samsung, let's say. Okay, you just do the final proofread and then approve it. So that we can make sure when the machines learn a new intent or enrich the NLP, then everything has been proven by human first. Okay, I think some people may think this is tedious. Why not you just do it in the automated way? As I mentioned earlier, it's not technical feasibility issue, but it's about if you ruined this one, okay, it's not likely that you can unlearn it afterwards. So especially for enterprise who are relatively more conservative, they would take the earlier approach that, or they rather proofread it first before we actually adopt to it. So all those garbage or meaningless, comments from the customer actually won't impact the accuracy of the NLP at the end.
I think the role of human is still essential for joining in the loop.
Correct.
Okay, I think we still got a few minutes, so I will at the same time enable the chat room functions. So if you still have any question outstanding or you want to chat and conversate with Terence, you can just type it in the chat room. Okay. Okay, what are the steps involved in solving the NLP problems? I think it's depends what kind of NLP problems you mentioned.
Correct. If you are talking about the accuracy issue, so we have to usually what we will come across usually some of the our scope has been miscategorized into the wrong intent. Then of course we have to find what are the data that has caused the issue. We run different regression tests to find it out. But if it is something that this is supposed to be in this intent, but it's not classified there, then so of course we have to look for the right data to train it, and then to see how we can improve it. But in most of the scenario that when we are running all this kind of regression tests, then it's all data driven, as also Sunny mentioned in the previous session, garbage in, garbage out. So the quality of the data is very critical. And when we need the ground truth, okay, something that someone has proofread, like the end users, they say, okay, this conversation belongs to specific intent. This is a ground truth that we have to follow. As long as we have this information, then we could have the data to supplement and enrich our NLP to make sure that the performance will be on track and perform as what it's supposed to be.
Okay, so I think one last question here from Wing. She says, thank you, Terence, for the fruitful sharing. And just one question left for her is, what is Terence's suggested effective way to collect data from different sources and then convert all data to be application in machine learning process?
Okay, so this is a good question, especially when we are talking about for enterprise. It's different for consumer market, because for consumer market, of course, we could grab lots of training data from different forums, from social media. Of course, we still use that source, but this is something that we would pay to build our base many years ago. But then as gradually when we are focusing on the enterprise space, this could be a bit tricky because business data is not something that you can easily collect from the outside world, frankly speaking. Even though we try a few ways, we try to pay people. So assuming that you are a customer for a telco or for a you are working for a car seller. Okay, how will you interact with the chatbot? And then we have someone to make up those questions, but usually those questions are not that valuable because those are really mock-up question provided by those people. So at the end of the day, so what we do is still we need to have live data from real customers. That could really help us. So I would say, so we have our base model. So usually what we would tell the customer is that, okay, we would do a pilot launch first. Okay, of course, we still need to rely on certain amount of data from live. So we do a soft launch. Maybe in the first month, we base on the data to further enhance the accuracy of our system. So that maybe we first launch out the accuracy maybe at 75%, but after we adopt another month of data, we could increase it to 85 or even more. So markup data is something that maybe we build the base model, something that we can leverage, but for real commercial deployment, we still think that the real live data from the actual users are more important. It's something that it's always surprises us. It's beyond what our developers or programmers can actually do. Even we do different kind of data collection exercise, with subsidized or different kind of incentive. Those data are still not as good as we thought. For speech, okay, in terms of the the general speech, it's okay, but for the industry specific jargon or slangs, then we still need to rely on
especially very relevant high relevancy
Correct.
terms. Okay.
Yes.
Okay, I think that's pretty much of the part 2 workshops of today. So thank you so much for Terence for joining us and presenting for all of our online audience. So we will now have a 10 minutes break, and part 3 will start at 3:18. So please grab your time for a water break or toilet break. So we'll see you soon. Thank you.
Thank you.
Hey, welcome back, guys. So welcome all audiences for back in today's data forecasting, NLP, and product recommendation application webinars. So we're entering the part 3 workshops now. So we have 2 guests here to share with us in these sections. So the first one is Mr. Chow Wai-Hei. He holds 5 years of experiences as a solution and engineer architect, holding experiences as a solution architect in different corporates and now working in Amazon Web Service. Chow has various certifications ranging from developers, system operation admin, solution architect, etc. So launched in 2006, AWS being exposing key infrastructure services to businesses in the form of web service, now widely known as cloud computing. The ultimate benefit of this new business model and turn capital infrastructure expenses into variable costs. Businesses no longer need to plan and procure servers and other IT resource week or month in advance. So Hayes also brought his colleagues here, Yan Wei, with us. He is the ML specialist solution architect at AWS, and he started machine learning research at RISA and has several years of experience building artificial intelligence powered industrial application in computer vision, natural language processing, NLP, and also online user behavior prediction. So let's give a big hand to both of our valuable speakers today to share with us on today's topics. So welcome both speakers.
Hi, nice to meet you all.
Hello, everyone.
Yeah, thanks a lot for joining our session. And again, thanks for the team to introduce ourselves. But again, let's introduce me and Yan Wei. First of all, I'm Hei, and I'm a solution architect from Hong Kong, and work for as an account asset, work to address different problem and solution for account. And today I bring my colleagues Yan Wei here, and it's our pleasure to introduce Yan Wei here. He is our machine learning specialist, and recently came to Hong Kong, and he worked for a customer in Europe for 2 years, right? And hopefully today we can have some chemical reaction when combining my observation from the local market and also your insights from Europe. Thank you.
Yeah, definitely. Hello, everyone. My name is Yan Wei. I'm a solution architect specialized in machine learning. And as a machine learning specialist at AWS, our role is to accompany our customer to advance their journey in the machine learning. Our job, of course, is to help customer to put their machine learning from the concept into the production. Let's jump in.
Yeah.
Machine learning is never a new topic. Actually, machine learning has been developed early in the 1960s, and for example, starting from Amazon, they have our machine learning algorithm in the website to bring the books to the correct customer. Those are the foundation of the product recommendation. And until so far, we still use the recommendation system to bring the good product to our good customer. Not only on our website, we do have the fulfillment center that requires a lot of machine learning algorithm to intelligently compute the correct routing, everything to bring the goods to the customer. And recently, we do have relatively recent, we do have a lot of developments in the NLP natural language processing area, where most of you might heard of the Alexa. And very recently, we do have the air drone, which are supposed to bring the goods to the customer by autonomous driving. And so our goal is to, let me just bring a little bit closer the computer, sorry. Our goal at AWS is to, let's first talk about the current state of AI, right? Current state of AI, we observe a lot of companies spend increasing amount of the money into the ML compared to 2019. We do spend triple the money. Why? Because actually machine learning can bring back the investment, can create a lot of opportunity. So currently we do have a lot of piloting projects moving to production, help business to advance further. And of course, those problems are not fake problems. Those problems are real problems, such as computer vision. Actually, yesterday I was hosting a show for computer vision or other algorithms to help to do the discovery, the disaster recovery. So that actually we do see a lot of machine learning algorithms can help to solve the real world problem, of course, including e-commerce problem. And the most challenging point is to how to maintain the machine learning algorithm. Machine learning is relatively new to a lot of customers, but software development is not new. We've been through a long history, 20 years, to put the best practice into the software development, to maintain the agility, to have the fast development, to have the CI/CD process. Now it's the time we see a lot of customers start to adopt the CI/CD or DevOps approach for machine learning. Those are several trends in machine learning, I will say, that help customer to move the machine learning faster. So our mission at AWS is to put machine learning for the hands of the every developer. And the achievement that so far, we have more than 100,000 customers using or try to put the machine learning in production at AWS. And we do have a huge amount of new services dedicated to each of the different services for machine learning that we will go through some of it today. Some of the surprising number, we do have 90% plus machine learning, especially deep learning workload running on AWS. For example, we have 91% of PyTorch model run on AWS on production. Those are the key numbers for machine learning, how our customer advance by leveraging our platform.
Yeah.
And I think, sorry.
Yeah, thanks a lot for Yan sharing about his observation on the global footprint of AI ML in our IT industry, actually across all industry to add on value. And also saying to my observation in Hong Kong market, actually starting from these few years, customer gain the inquiry of AI ML to address their solution at their pain point to both increase their business value and to lower their operational loss. And to be honest, this is the same observation from the global, to be honest. And so thanks a lot again for Yanwei's opening. And for me, that shows how AWS provide service to address for your AI ML solution. So we will share this screen with a lot of service, right? Or even for me, it's very there are a lot of diversity. But let me guide you to walk through step by step. So we classify this AI ML stack into 3 layers. Starting from the top layer, which is called AI services. You will see there are a lot of use cases, such as the top layer, the top row, we have health, industrial, and then the second row, we also have computer vision, NLP, and also some business tools like recommendation and focusing, which is very correlated to e-commerce industry, retail industry, right? And later on, we will share some main service that can help you to address. And with less effort, go to business and simply provide the data, and it will with an API-based solution, then you will just get it just in one shot. And later on, the middle layer and the bottom layer, I will state it as more on machine learning, that you will have your own development on your machine learning model, and you have your data science are working on it, but they have some bottleneck in running in a local environment. How cloud can help you to benefit in machine learning point of view Then later on in the second half, we will share this session to how to accelerate your ML development lifecycle. So yes, here starting from, we will focus on AI service. So which service I will bring you first? For sure, the Amazon personalized. What is that? Let me ask you a question. Have you experienced the power of product recommendation? I would say yes for myself. Just a few months ago in the Black Friday, actually I'm a consumer for Black Friday event, and then starting from buying the first product, that recommendation engine start to introduce relevant product again and again and again, and finally I can tell you I would buy like tens of products, and yeah, I have to explain it back to my wife, and then but in this way I pay a lot of money, but in business point of view, it's definitely a good insight to raise your business efficiency. So therefore, Amazon personalized solution, managed AI solution to help you to develop the recommendation engine in a short period of time. So let me share the current landscape that actually from some statistic, around 63% of customers, they consider the product recommendation service as a standard in different applications like e-commerce or maybe media. Let's see, maybe Netflix, everyone is using now. And what is the power of personalized behind? You can imagine, first of all, to drive more revenue, like my exactly my use cases. And the second one is, apart from having more acquisition retention, you can do more engagement by the data from the recommendation engine, like by measuring the click rate, etc., and to do further maybe marketing campaign. And also assure the efficiency and revenue you can leverage that to increase by recommendation engine. Finally, discoverability to understand more about your customer. So you talk a lot about what is personalized. Can you give an example? Here you go. I'll show you our global customer successful story, which is a lot 10 miles. If you go traveling a lot into Korea, definitely you heard of lot 10 miles. Maybe Japan as well. I'm not sure. I'm not, but definitely at least in Korea. And so, what is the problem they encounter? They want to increase their customer loyalty, but the problem is they have their rule-based recommendation engine they built themselves, but they found some pain point that it cannot help them to drive more revenue from new product because they don't include those rules for new product. That's how machine learning brings the power in. But they use Amazon personalized and to analyze those the success history, product metadata, and assure the user profile. And Amazon personalized can even help you to introduce new product to your existing user base. And finally, they increase the product purchase of 40%, which is a very significant business revenue. So let me put on the ground, how does it work for personalized? Starting from the left-hand side, you will see these are the input data you have to provide. That's you as a customer have to provide. What are the free data? Actually, I believe most of you have already stored this kind of data, starting from from the bottom, user metadata, right? You have to store your user, such as their age, where do they live, etc. And then next, there is user, and that must be product as well, the item metadata. You store your item information like the color and the size, or even the brand, etc. You have item and user. And finally, the third data you have to provide for training the personalized would be the interaction, that is between which user purchase or view the item. Okay, so if you have these three set of data, that's it. Actually, you don't need to do a lot of workload in the model building and model tuning side. Actually, you can see the right-hand side one is fully managed by Amazon personalized. Every step inside in the green dot will be managed by personalized. That you don't need to spend a lot of time in tuning that, etc. And what you have to do is just simply implement that API endpoint to your application, and that's it. And it will help you provide those real-time recommendations. So let us show you the result. One sample result is you will see that is actually a real-time user personalization use case. Starting from the left-hand side, you will see even we mentioned in Notema, it will help you to introduce a new product to existing customer. Actually, you can also suggest existing product to new customer. Even you don't have that user item data, but you can still also based on personalized suggest the trending data, which item a click or purchase the most amount. And then even further, it will help you to continuous learning the user action, like once they click fill items, and then you Amazon personalize and further help you to recommend that personalized data to that user, which is very powerful from the point of view. So show you how does it look like, how does it work for personalized. Let me also quickly cover what we announced in our reInvent 2021. And in reInvent, we normally introduce a lot of new service and feature, including personalized. Here I bring in two. The first one is the user segmentation. Don't underestimate that. Actually, it's really powerful that help you to grouping your customer in based on their similarity. What is the use case of that? One very typical one should be the marketing campaign. You can do more customized marketing event based on those customer base, or even send those marketing email with the personalized feature, which even further help you to improve the ROI. And the second one is more even relevant to retail is we have optimized recommender for the to industry like retail, as we cover the industry today. So you can see you don't need to specify those recommendations in engine. You just, when you train the engine, you select that domain, retail domain, and then it will help you to learn based on the user action, the purchase and view, and then it will help you to customize the recommendation based on retail domain, like customer who will, which item also will or frequently bought together. Actually really familiar, right? You will see a lot of similar suggestions in the e-commerce platform. So he is sharing about personalized recommendation, and we're bringing a lot of benefit for e-commerce platform. I hope you can enjoy and then to start to boom back your use cases, and it will help you. And actually, we'll show a lot of managed AI service apart from product recommendation. Yeah, we do have other service to share to our audience today, also related to e-commerce and give advantage on their business.
You mean other service? On top of my head, it's like you see from here, it's forecast. Forecast actually can help you to forecast the outcome, business outcomes, in the way that it's accurately forecasted and very simple to put into production. What's the power of the forecast? First of all, what's a pinpoint of some of the sectors such as e-commerce or retail? The pinpoint is that people really need some of the forecast help them to make the decision. However, such solution needs to be accurate. If it doesn't, it's not accurate, then it's not very helpful. And it's supposed to be easy, because imagine the scenario where we want to put the forecast system on production. If it's too hard to maintain, then probably it's less useful or less maintained, and sooner it will be no use. So those are several points that the sector suffers. As AWS, we try to address its pain point by providing a simple solution which can help customer, like you can see as a statistic. If I think it's a study from Gartner, where people think that have a better accurate forecasting system can help them to manage the inventory or predict the sales, etc. Those are the pinpoints and the solution we want to bring to you. At AWS, we do have a service, like I mentioned, called Amazon Forecast. Amazon Forecast focuses on several different areas for the business use cases, including inventory planning. Imagine a scenario where you have to, like Black Friday, right? If you have to prepare the inventory. If you can better predict the sales of certain products, then the inventory can be managed. And also the workforce for example, for Black Friday, so that you can in advance you can plan your workforce to handle the traffic, etc. And those forecasting systems have been also used in the financial area, maybe in the e-commerce sector as well, where you can perform the capacity planning and the financial planning as well. So basically, there are many use cases that you can solve. Basically, Amazon Forecast is time series prediction system where the only thing you need to provide is your historical data. Of course, you can bring other data as well. I will explain later, but forecast system is based on the historical data. Try to predict the future. That's it. So based on this use case, you can imagine probably the inventory planning, something I mentioned previously, or other innovating things. The concept is pretty straightforward. Why not forecasting system is in production everywhere? Well, here's some state of the forecasting system where we can see actually starting from very early beginning, because the customer always needs the forecasting system. The requirement is there, the need is there, but for a long time, we do have very simple way to provide the forecasting system, such as manual planning, where you can put the number in the Excel and do some manual calculation. You can set up the rule. You can use your sales team to plan the future. However, those are very conventional methods, but things start to change recently. People start to realize that the machine learning algorithm can help them to better accurately and better modelize the patterns, right? So that in the retail or e-commerce system, you probably have thousands of items, which can maybe very hard to be handled by human beings, right? You probably have a lot of related data, such as the weather, whether there is a promotion, whether it's a weekend, something like that. Those features is, well, for human beings, it's difficult to take into consideration because we can only modelize some basic pattern in our mind. However, machine learning, especially the rise of the deep learning, can help us to modelize the complexity patterns within the data in your historical data and project the future in a very accurate way. So here's a forecast under what's the technology behind the thing. Actually, what you need to use the forecast, what's the data you need to use forecast? Basically, you need to prepare your historical data. This data set is mandatory data set where you have to provide, because those are the things you want to learn from and try to predict. However, you do have the possibility to bring other data, such as related item, related data sets, meaning that imagine you want to sell something and there is some curve about whether it's in promotion, whether it is a weekend, or weather index. Why not? So those are called related item. Of course, you can associate the metadata for each item, such as the price. Price can contribute the sales, such as the color, such as anything related to the item. Those data sets supposed to boost the performance. The only requirement is that you provide a historical data set, and Amazon Forecast will manage the several steps of, like every machine learning project, but Amazon Forecast is managed from the input data set cleaning, feature engineering, hyperparameter training and deployment. Everything will be managed within the Amazon forecast. And not to mention that after the reinvent last year, we do mention a very critical features for most of the business. How to explain my time series, how to explain my features. Those explainability can help you to better understand why the reason the products have been skyrocket, or no one can see the no one can actually the product is in the low sales. So those are the explainability is one of the most required feature I will say for the Amazon forecast. And here is an example of our customer in retail by leveraging Amazon forecast. They do have reduced 30% of the inventory planning because actually if they can predict the sales better, then they can manage the inventory better, right? Those are some of the use case that help customer in production to reduce the real money. That's the forecast. Let me jump to the next slide, and the controller doesn't work. Okay, thank you. Okay, that's forecast. If there is a lot of things that you start to feel that okay, I have a lot of use case, I have my data, but I still need to upload my data set. First of all, your data is supposed to be your data. We'll never leverage your data for Amazon forecast and Amazon personalized. You need to provide your data. What we call applied AI services, meaning that the model is supposed to adapt in your situation. However, next service called Amazon Comprehend is API service where there are lots of built-in model for you to leverage. You don't even need to provide the data. You can use the service as it is. This is the NLP service, natural language processing, for understanding the text in the document. So what's the Amazon Comprehend can do? Actually, what you need is to provide some of the text, and of course, you can select the task you want to accomplish, and you just feed data into the Amazon Comprehend, and Amazon Comprehend will perform the inference. Those there are some interesting use cases that you can leverage, such as entity detection, so that you can or key phrase extraction. You can probably analyze your test, your review, and extract only the important thing. Of course, you can use the sentiment analysis to classify the review from a negative, positive, or neutral. There are other interesting use cases such as PII information detection, where if you have a lot of comments and your customer leaves some of the sensitive data, and in your data cleaning process, you can leverage the Amazon Comprehend to identify which part is the PII information, personal identifier information, and mask it. You can also perform the document classification or sentence classification. You can use the standard templates, but also you can use your own templates. If you have a use case that's dedicated to your use case, you can leverage Amazon Comprehend by customize the label, so that Amazon Comprehend will give you the output as you expected. That's the NLP process.
Yeah, really thanks a lot for sharing, and actually thanks, especially you picked these very relevant and precious, meaningful feature for e-commerce use. Especially, I do have customers asking for using forecast for their sales forecasting or inventory forecasting, and also for Comprehend as well. I really need to mention that because you mentioned a very good point that they even don't need to bring their own data. We do have our already pre-built model. You simply just need to use based on API. that use it for checking the sentiment analysis, the review whether it's positive, negative, and then to take action based on their priority. And even further, they based on those entity or key phrase, they can detect those keywords, what kind of problem customer mentioned mostly in their review, or even further in those chatbots, like those conversations, they can also leverage that data to check what kind of complaint or compliment customer normally give. So that's all of our sharing about the first half. Not yet, we have said second half. It's about those managed AI service that you simply just need to bring your data, or even you don't need to bring your data, you can quickly leverage our managed AI service based on API, then to go to market, put into your product. But in case, what if you want to build a custom model, you have custom use case, like I want to build a special classification, regression, or even some deep learning use case. What should we do? Or on the other hand, I'm already building my model. Why still need to? Why can't I keep enhancing my model? Actually, you can. We have the second half of service. Let me introduce our core managed ML service called SageMaker. So jumping back to this AI ML stack, again, for the free layer, let us focus on the second and the bottom layer, which is our managed service SageMaker. Inside, you will see it mentioned a lot of features inside. I will walk through what is the core method of using SageMaker as well. And also the bottom layer, which is the framework and infrastructure, is very closely related to our SageMaker that will provide underlying infrastructure or some optimized framework and runtime that you can leverage on top of SageMaker as well. So to start with, what is the benefit of SageMaker? I believe everyone have to know. So we point out three major benefits. First of all, for sure, accelerate your development. By using cloud with our scalability and elasticity, you can put your development work much faster, more efficient, like agility. And also, SageMaker, we do have a lot of tools to help you to do so. Second part, don't forget that we have a team of collaboration for developer or even data science. We also have some ways or features to help you do those to collaboration for the productivity, like sharing the workload, sharing the feature, etc. And okay, so finally, the third one we mentioned is the reduced cost. Not only the infrastructure cost, I want to repeat, not only infrastructure cost, you can save from using cloud, and also the operational cost. That is really critical. That by leveraging cloud, actually the core cost of optimization would be one part is optimized operation. Normally, when you do some development, even for application as well, when you do development, you need to do a lot of feature enhancement, or for data science, you have to do model tuning, etc. And then later on, you have to implement to some testing area, and then do recurring tests and finally production. Normally, it takes months, I would say. But by leveraging cloud with those agility, then you really can benefit from deploying from months to weeks or even to days to accelerate your product lifecycle, and even with less operational costs like human labor. So okay, can you show me what is SageMaker? Sure. Let me show you how does it look like. Look at the right-hand side. You will see, actually, we are like Jupyter Notebook or Jupyter Notebook is a place for you to implement those Python coding to build your model, and also with some building tools to show like graphical or tabular data as one shot for using a SageMaker Studio. But a lot of people, they misunderstand SageMaker as just an IDE platform similar to and managed IDE platform on AWS. Actually, the beauty of SageMaker, I would say it has features to cover every step of machine learning, starting from data preparation, to build a training model until you deploy into production environment. We also have to cover those. So not only the IDE, let me show you. For the machine learning development, actually, as you're working on that, I think this will catch your eyes and raise your memory before, like starting from data data handling, labeling, collecting, preparing, right? And then followed by you have start to build your model, what kind of framework, what is hyperparameter, I need to do a lot of recurring. And don't forget that you now, as Yami mentioned, now more and more AI ML services are put into production use. So don't forget for production, actually a lot of other things to consider, such as the scalability, security, etc. So SageMaker will help you in all along the way. So can you show me what kind of feature does SageMaker have? Actually, really a lot. Oops. Let's show you put into the ground what kind of feature we do have. Actually, we do have a lot from, as I mentioned, for different steps of SageMaker, from preparation, build, train, and deploy. We classify in 4 stages. And we have no time to cover one by one, but we will break some, we think is really useful for your side if you're doing machine learning job right now, especially you're doing in your local environment, on premises. And this feature will definitely help you, because I do have some customer, they mainly ask for first two main questions. First, I have some pain point in doing, I am doing machine learning training job a lot. I train a lot of model, but I have some limitation in computer resources on-prem. How can AWS help me in help me to do it effectively? The first question. The second question is, I already built some model, but is there any way for me to deploy those machine learning model effectively without handling a lot of manual work? So today we will focus, first of all, for me, I will focus on the managed training part and managed deployment parts. So first, for training part, let me show you the flow of doing model training. I believe most of you, if you're doing machine learning job, definitely you have notebook instance, right? I have one, you have one also, right? And then, but the point is, and can you imagine if you do a lot of training job for different use cases at the same time? Actually, your local compute will have a bottleneck inside. So in SageMaker, how does it work? Actually, we decouple the notebook instance and training instance. Starting from the top, when a local instance trigger a training job, then SageMaker will have to manage that training job by spinning up those training instances we call in the middle one, and then regarding runtime, we'll provide you the container. The container is a lightweight environment, including those runtime like Python version and also the framework version. And we do also provide some, we already have some optimized the deep learning and machine learning container for your use. So don't worry that you have to also to build container. And then followed by the first step, the data. Actually, those data we suggest customer to put into S3 as a data lake to store all kind of data. So in this case, and then we'll get the data from S3. And finally, you'll see after training that we'll return the result and even train model back to S3. Actually, there's no vendor login because your model, actually you can simply download that, such as PKL, PDH file, that trained model in S3. Maybe you can have further use like deploying a flash, etc. So yeah, I can see the flow. But let me show you the code. I believe everyone feel comfortable when seeing the code. So when seeing the code, most likely the same as that process flow. You see there will be three lines of code, starting from defining your estimator. Within the estimator, you have to put your training code inside, or even further, no specialized training code. You just simply define that container for your training environment. And then followed by the number of instances, because you can specify, you can do some training, you can distribute your training into multiple instances in some way. And also for sure the training instance type, like you use CPU or GPU instance. And then that's it. The next followed by you set up some hyperparameters. Every machine learning algorithm should have some parameters like epoch, right? And for the final step is just dot fit, same as what you do when you do scikit-learn, pretty much similar. Then fit your training data inside. and that's it. At the back end, it will do the training job in those training instances instead of your local. So regarding those, the algorithm, if someone may ask, okay, I'm using some dedicated framework, does it support? We definitely support. You will see that from this slide, we have 3 paths starting from left-hand side. If you don't have some preference about the algorithm, I want to start to explore that. We do have some built-in algorithm for different use cases, from basic classification regression to some deep learning, like event forecasting or natural language processing. We have. And if you are using your own framework, like if deep learning like TensorFlow, PyTorch, actually I keep hearing from customer, and even further, customer, they are asking for scikit-learn. Actually, we do have not only deep learning framework, but scikit-learn for XGBoost also. And one more update last year is we also support the new a trend of natural language processing framework called Hugging Face. We have customer keep asking natural language processing related question. We got related to Hugging Face. I observed this trend, and we also support that. You basically bring your training code, and then we already provide those container as a runtime, including maybe like again the Python and the framework version, even maybe the CUDA, you already include inside container and also optimize that. Okay, but if I am more advanced, I do have some other library I have to include. What can I do? We do have a flexibility for you to build your own container, like to extend our provided container with additional library, or even further, you build your own container from scratch. We also have flexibility to do so. So therefore, to train your model using SageMaker, what are those benefits and features you can benefit from that? Okay, so first of all, you can leverage our different instances for sure, and also as I mentioned, you can do some distributed training. Like when I do one training job, actually I can distribute to multiple instances to do so, to enhance the performance and efficiency, to lower the training time. And also the hyperparameter tuning. As you know, we always have to struggle to what kind of hyperparameter are the best combination. You don't need to guess. You can use our feature, the automatic hyperparameter tuning. You specify the range of hyperparameter, and the rest you leave it to SageMaker. Don't forget, it will help to spin many training instances and help you to try with different hyperparameters combination and to search for the best to do so. So this is a very good example of leveraging our cloud benefit, which is scalability and elasticity. No bottleneck from having your own compute resources or maybe GPU card. And finally, also one good benefit is you can preset your training log. Like your application, we do provide service for you like CloudWatch to store your training log, that you can trace back your training job. What does it happen? How does it work for each epoch? You can do so. And again, we do have update in training part. First of all, training compiler, you can use it for even optimize your training job with that specific instance type by compilation. The second one is Trainium, which is a chips that developed by outside AWS to mainly specialize for doing training job, which is considerably the performance compared to those GPU-based instances. So first up, the training part. How about the deploy part? Actually, if you consider the deployment, not only to deploy into one single VM, for a production environment, you also have to consider those resilience, availability, high availability, and also scalability, right? So by using our managed deploy, you can bring your trained model from SageMaker, or even you bring your already pre-trained model. You can deploy on SageMaker and simply 1 to few clicks, then you can deploy SageMaker with a stack with instance, a set of group of instances, starting from one instance, and you have the ability to scale out, and also on top of a load balancer. Then you don't need to handle a lot with spinning EC2, ELB, etc. So apart from auto scaling, any other benefit? Definitely there are. First, I will mention if you want to do A/B testing like application, you can also do that in machine learning. So in our managed deployment, we do support to do that A/B testing by setting the weights of the traffic into a different model. You can do so in our endpoint. And also for further the monitoring, not only the compute resource monitoring, such as GPU utilization, but also your model monitoring, which is to keep track whether your model quality can withstand with the high accuracy by the time goes on, such as maybe there might be some data drift of your customer base, or your model quality with some with degradation in some reason. It will help you to monitor and notice you. Maybe it's time to retrain your model, right? So again, we ran a lot of updates also for the deployment part. First one I will mention is the inference recommender. Help you to suggest the right inference, the instance type for you without struggling from what kind of instance should I say that. It will have some load testing to help you to check which instance is good. And second one is serverless inference. Yeah, I have to mention that we have real-time inference to give you the response in real time, or maybe you can do batch inference, like maybe a schedule a time to do a bunch of data to return the result. We have one more new inference type called serverless. And if you do a lot of development in AWS, definitely you heard of serverless, this concept, which by using the Lambda and to have a pay-as-you request. Once customer request, then your compute resource spin up, not to open run the crawl. So for machine learning, also we also have this new launch. You can leverage this concept and benefit in deploying your endpoint as well. But some bear in mind, maybe first of all, it's in preview that it's not yet generally available, so we don't suggest customer to put it in production work. And second one is there are some limitations like not yet support GPU at the moment. So maybe if you want to try the SageMaker deployment, then you can have to do some research or research out, and then we can seek for the best way to deploy. So this is the sharing of my side about using SageMaker in training and deployment part. I believe Yan-Wei and also have some global insight that when he experienced a lot in the past in Europe, and that have more core feature to further enhance customer ML lifecycle, right?
Yeah, definitely. Actually, thanks a lot for mentioning those services. These are really key foundation of the machine learning, the training, deployment, different compute instance, such as here, because during the training, you might need a GPU, but for the inference, you might not need a GPU. You can leverage the CPU inference for reducing the cost. Of course, you can still use the GPU, it costs more, but the model latency and model throughput will be different. We do have different type of the GPU, CPU from Intel, from NVIDIA, etc. And we do have our own chipsets, such as Trainium. For training, it's an ASIC chipset, application-specific one, and also the Inferentia for inference. Those are different chipset that we bring to our customer. I also want to draw attention to the slide where we introduce the training concept. It's not necessarily based on the Jupyter Notebook. Jupyter Notebook is only the entry or the place where you can execute your Python code. A lot of customers don't prefer Jupyter Notebook. They prefer IDEs such as PyCharm, such as the other IDE. They can still leverage the SageMaker for their training. They can combine the training from the local instance, and when they need the HPO job, hyperparameter training, they can leverage the scalability of AWS to train multiple models at multiple times. So those are key foundation of the machine learning. As a data scientist, if you have the capacity of the training and the capacity to deploy in a production-like environment, then you can test your code in production, or at least the collaboration between you and data engineer or infrastructure team will be much easier. And talking about the collaboration, we do have our last part called machine learning plus operation. It's a new term called MLOps, and now everyone is using that. So last session will be focusing on how AWS can help you developing MLOps foundations to modernize your ML platform. This topic will be a continuous as the machine learning platform based on SageMaker, just to differentiate the AI services where you don't necessarily need to understand the algorithm, need to understand the machine learning. You can leverage our AI services. Here, you have to be in-depth knowledge about machine learning because what we can help you to do is to provide a platform for your data scientists, for your researcher to develop their model on AWS because they can benefit the agility, the scalability, and here now put into production. Here's a statistic of Gartner estimation of machine learning, advancement of machine learning, starting from the last decade. We have a lot of pilots, we have a lot of research concentrating on the algorithm. However, now it's not the case. Now, today we can see a lot of machine learning has been put into production. However, today they are based on this estimation, there are still half of the project is not going to production. A lot of reason why. I think one reason is that the model is not good enough. However, we do have a lot of advanced machine learning algorithm can provide good solutions, good accuracy. So I guess, and based on the study, the second reason for the project not go to production is because data scientists might want to concentrate on the code for algorithm, but the handover to machine learning engineer, infrastructure team is so difficult, then they put forever to put into production. However, now Gartner estimated in 2024, 35% of the machine learning project will be in production. So this is the moment where AWS want to capture the moment and try to provide a platform to help to increase this ratio from 50% to 75%. How? By finding the reason how AWS can help our customer to put into production quickly and provide better collaboration environment. We have to understand, we have to focus what is the machine learning process. Like you can see here, I'm sure that most of you probably already knew this picture or already did your previous project based on this template. This is only one template illustrating that you, as a data scientist or machine learning researcher, you probably start thinking about your problem at the top and find out a framework for machine learning or problem framing into one of the machine learning frame. And then you start to get hands dirty by data collection, data visualization, analysis, feature engineering, programming to program the code, and of course, training. And the training can have a lot of training in parallel. You can continue to iterate your process, and until the end, you have to evaluate your model. And based on the evaluation, you may either go iteration because the model is not good enough. You can also decide to put into production. And once you decided to put into production, you still need to monitor the job. Why? Infrastructure is one hand. Like he's mentioned, you need to monitor what's the latency, what's the throughput, etc. Probably you have to check your instance, whether it's auto scaling, whether it's good enough to absorb the traffic, etc. But you still also need to monitor the accuracy, because if it is it's what we call model drift or data drift. If your data is different, it's so different than your training data, then you are guaranteed to have a very bad result. At that time, you probably need to still retraining your model. So those are typical ML process. And based on this process and based on our experience on customer to put machine learning into production, we have two phases. The phase one is research phase. For the research phase, most of the question will be how this problem can be solved by machine learning. Do I have enough data? Can I try this? Can I try that? So that in this phase, you do have the since you have to train the model, you do have to do the data collection, exploration, feature engineering, everything. But the concentration will be on model. You have to program a good solution for your data to train on your data and have the better solution to evaluate the model. So this phase is called research phase. Once you think the model is good enough, probably you are going to the operational phase. In operational phase, as you can see, the ML code will be a less focused part because you got your code already. However, the other part became important, such as data collection, visualization. Probably don't need to visualize, although some customer may need the visualization of the training data set, but collection of the data, feature engineering, everything will be automated. Why? Because in a real production system, such as recommendation system, the recommender sometimes needs to retrain based on a 2-hour basis, meaning that each 2 hours, you need to train your model. You cannot request a data scientist to work 24 hours per day to stay aside of the computer and do everything in order to retrain the model, so that everything's supposed to be automated. This is the second phase for operation. Of course, there will be a lot of questions such as how I can put into production, how I can monitor my job, how I can integrate the CI/CD part, continuous delivery, continuous development part into my machine learning, how I can teach my data scientists to collaborate more with infrastructure team, to data engineer team, how I can let data scientists have the capacity of deploying on the production system. Those questions are very hard because we do suffer a lot 10 or 20 years ago from the software development where we do a lot of hot fix. We don't have the CI/CD pipeline. Now we don't have this, well, we still have some of the problem, but now CI/CD is become a standard of software development for agility. How about machine learning? Actually, machine learning is even more complicated because machine learning, you still have to have the code, but you do have to provide the data, and code plus data put through the training job, you got the model. So these pillars may change. The code changes, the model changes. The data changes, the model changes. So those are complexity of the machine learning. To put into a good picture, here is different machine learning life cycle that most of the customer or most of the company will go through. Starting from the code, imagine the scenario where the code is ready. You need to train your model. Once the model is trained, you need to evaluate the model on the test data set. And if you think the model is good enough, you probably want to save the model, choose the model registry. If the model is really not good, you don't even bother to save in the model registry because it's not useful at all. Once the model is in the model registry, you probably want to, as a data scientist or as a business role, you probably want to compare different models. So that model registry is supposed to give you the possibility to compare different versions of the model. And once the model is approved, now we will go into the code and the model will go to the production or release pipeline, where you probably need to run multiple tests of the integration tests to test your API, to test the whole system, whether it works correctly or not. And once you probably will go to the pre-production system or environment and production environment, where you need to add your manual approval, etc. And once the model is in the production system, you need to monitor the model. If something happens, probably data drifts or accuracy is lower than previously, then you need to retrain the model, or you need to retrain automatically, or you can require to work on the new version of the model, a new code. So those are ML lifecycle management, and how AWS can solve this problem. I think 2 years ago, we do bring SageMaker pipelines as the ML platform to our customer. SageMaker pipelines includes several components, which the first bit starts with the ML project. ML project is code together with built-in triggers, which is really the foundation, a Git repository we can see to help you to trigger the CI/CD pipeline, or to maintain the code, or maintain different version of the code, of course, or to increase the collaboration. If you have the project will provision several things together, including a template of pipeline. Pipeline is actually an orchestration system, because machine learning, we do have to go through a lot of steps, including feature engineering, including hyperparameter optimization, multiple steps of the feature engineering, right? And the training and validation, etc. So those pipelines supposed to be orchestrated. SageMaker platform help you to provide a free orchestrator. You only pay for the worker on each of the tasks, but the orchestrator is free and it's for scale. It's ready for scale. That is the second step. And if your code goes smoothly, you will have your model registry. Different version will be registered in the model registry for you to compare. What does it look like? So this is the SageMaker pipeline UI in production, where you can see green means that the pipeline is advancing, and if it's running, you will see a circle. Those are the pipeline. In the pipeline, you have multiple. We do provide multiple steps, including pre-processing step, or processing step in general, training step, condition step, how to register model step, or a step that you can define anything, which called Lambda in AWS. Lambda is our service compute platform to enable you to leverage other ecosystem. These are orchestrator. Of course, all the metadata will be stored in the SageMaker Studio, so that you can easily track every step. You can check the input, output data, etc. Those are SageMaker pipeline with model data tracking, data lineage tracking more specifically. And model registry, it's a place where you can see all the model together and compare them together with different evaluation metrics, such as accuracy, RUC, and the ROC curve, and a lot of customer metric that you define, it will be shown here. Model registry also give you a possibility to validate the model. As a data scientist, you can validate the model, and the model will go through the release pipeline. If you can, as a data scientist, of course, you can reject the model if it's not good. You can always choose the best version of the model and let the model to go through the release pipeline. So here we have the built-in trigger to allow data scientists to validate the model and trigger the next pipeline. And to sum over, MLOps here is the very simple template to illustrate how SageMaker platform can help you to build a sophisticated, powerful enough ML platform for your data scientist, data engineer, and infrastructure team to work together. It goes through the data scientist to provide the code, to trigger the pipeline, and pipeline goes through different steps of the training. And after the training, the model will be stored in the model registry, and someone validate the model. It goes through the release pipeline to deploy, whether in the production system on real-time inference, or you can, of course, imagine the batch processing use case. In the release pipeline, it's independent of the machine learning because you got your code, you got your model. So basically you have everything. you can integrate the solution into your existing infrastructure team. So here is one simple illustration of how SageMaker pipelines or SageMaker provides you ML ops platform. And really hope that it can bring some of the insights for you.
Yeah, really thanks for Yanwei sharing. And actually, it's a very fruitful session about ML ops, which is a term that helps us to take one step further to ultimately enhance the machine learning lifecycle. I've also had some sharing about that because definitely I do have customers starting to ask for the ML ops in addition to doing the machine learning job. That we start to do some POC about the focus on the model deployment stage. As you can see the right-hand side of the flow, that we do provide a service called pipeline to help you to do the model deployment and into different stage, like into a test stage and production stage. And also in my case, actually, we also have flexibility to use other third-party pipeline, such as Jenkins in my case. And then the final flow will be immersion customer. Once they finish training the model, they start to upload to the model registry with the versioning. And then, wow, next is to trigger the pipeline. You need to do nothing by defining that pipeline. It will help you to deploy into different environment by installing those library and then to deploy into testing stage. And then with a manual approval stage to help you to deploy in production environment. Maybe in different account or even different region, you have the ability to do so. And then I believe followed by one step further into the training part, I believe by using the SageMaker pipeline for the training part, you even further ultimately enhance the machine learning process, like maybe triggered by new training data upload, or maybe as the schedule, maybe end of the month, or even further for some alert from the model degrade performance, and then start to trigger the training pipeline without any manual work, I would say. So it's a very, very awesome topic. So almost the end of our sharing, and we always talk about how to get started. What is the next step? I would say starting from the first one, for sure, discover your use case, or if you have a use case, do get your hands dirty, such as for us to do POC with customer, or if you have some use case, but if you want to have some external resources, we do have our partner network to help you to explore and also to evaluate and even further implement your use case. Or on the other side, if you want to do by yourself, we also AWS side, we also have resources to walk through the POC journey with customer together. And finally, we have a lot of the training and certification for different topics, including the machine learning. So it's very fruitful, especially the certification one. I highly recommend because I took it before and I gained more knowledge for myself. So that's it for our sharing about the AI/ML service from AWS, how to provide different point of view, how to go to market or improve your efficiency and productivity in the machine learning workload for different user bases. And finally, for that ML ops, definitely it would be really helpful for you to accelerate your ML lifecycle to reduce your operational costs. So yeah, thanks a lot. So
yeah, thank you.
Okay, so thanks a lot for Yanwei, and he also presents so much, especially on how AWS machine learning products, how can this powerful tools maybe benefit to all the audience here. So we have 10 minutes for upcoming Q&A sections and networking sections. I will directly enable the chat room functions. So if you wish to conversate, or if you have any inquiries, no matter on the AWS business or applications, or you have a personal question that you want to ask about Yanwei or Hey, you can just leave it in the comment section now. So I have already saw some questions here from our audience. So if I have no experience in AWS, where can I find a resource to start with and learn? Especially when I heard of the AWS machine learning certification, a lot of different class and materials.
That's definitely a good question. Also, I have this question myself as well. So from my experience, first of all, share my experience. First of all, to learn in AWS point of view, apart from the AWS product page or documentation about the product, actually, I highly recommend you to reach our AWS blog. We do have a session about machine learning. Actually, difference between the blog, doc and documentation and blog. Documentation more on like instruction guide for how to use the service. But for the blog, we do have a lot of expertise like Yanwei. We have sharing about the use case basis from some experience working with customer use cases or some other new feature launches for and even further to how to leverage AWS service to work with those newly framework like Hugging Face. And then it's really good. I study a lot from there as well. Thanks a lot, Yanwei. And then within that, still have a lot of step-by-step guide to guide you how to implement, put it to the ground. This is first part of the ML blog that I really highly recommend. And for Yanwei, do you have some?
Definitely, AWS machine learning blog is one good place to check. You do have also, if you don't want to read, if you want to a visual, you have the YouTube channel where a lot of customers actually share a lot of their use case in the AWS official channel. You do have Crossria if you are a student or some beginners. You have the Crossria how to do machine learning on AWS. Those are resources available for you.
All are free resources?
Yeah, sure.
I hope it's
relaxing to be free.
Okay, so like how to mitigate the overfitting problems? Is this a common problem in the machine learning field?
Yeah, definitely overfitting is quite common, and how to mitigate it. I think a lot of algorithms have the early starting. It's already built in. But for our AI services, you don't need to worry about the accuracy because every accuracy and every metric will be shown to you and will be tested seriously on different, for example, on Amazon forecast, you have the possibility to choose different backtest window so that you don't, if you see overfitting, then you know for sure that the model is not good enough, but you do have a lot of place to check your accuracy for your own model, of course.
And also have some insight about regarding using SageMaker if you build your model by yourself. And SageMaker is one feature. I mentioned there are a lot of features. One feature to have is called SageMaker Debugger. I've shared inside the SageMaker Debugger that it has several information about during your training job. We do have some detection and recommendation, like exactly the overfitting detection and suggest when to do other stuff. In addition, also suggest you such as the GPU resources not enough, then you have to select another instance type to have a better GPU performance, to do a better training efficiency result.
I think that's a perfect solution for especially not a very specialist in this field, but he or her want to try more on adopting this kind of technology, right? Okay. Okay, we can.
I also see there's a quite meaningful question about. This is a very good question about how to do the first step. Actually, we mentioned a lot of doing AI and ML, but the key part is data, right? How do I get started? From data point of view, I have a lot of data from everywhere. How do I do? Actually, this is another very good question. A lot of customers I engage ask about this question, that they have a lot of data, maybe starting from most common place in database, or maybe an Excel file or image file in your local environment. Then you can consider a lot of, even further for enterprise one, Oracle database, SAP. How can I collect all of them and to aggregate all of them and to move on to the next step? So in our part, this is actually another big topic, which is our data analytics. But I can have a high level sharing about the key is the data lake, which is actually our S3 solution. Maybe many of you use S3 for storing data, maybe host web, doing backup because of the durability, high availability, right? Actually, that's one key concept using S3 is to do the data lake solution, to place whatever data you have to S3 as a single source of truth at the first step. And then like database, we have some service to help you continuously replicate data to S3 as CSV, or maybe some file-based. We do have some maybe API call or FTP solution to upload your file on it. And then even further for let's say that there's a lot of solution. We will in case by case pull like some special data for Salesforce, etc. We also have some service to pull the data in. And then, okay, move on after S3. Is it all done? Not yet. Actually, those we call the first stage, which is the raw data inside S3. And from the data source from the data from different data source, they might have relationship in between, but how to link with each other, or on the other hand, I want to do some data cleaning. Well, there are a lot of messy data, or maybe I have to do normalization. Then we do have some further service to do the ETL, extract transform load, which is the glue that basically it is you can implement your Python coding or even Spark to do the data processing job. And later on, you can store your processor data inside S3 again. And then later on, you can simply consume the S3 data for machine learning. Or even further, you want to do further like query in S3. I want to query CSV file. I want to query JSON file. And how can it be done? We also have service to do, which is called Athena. Then you can do query from the Athena and then to obtain the relevant data for training.
Definitely, I think if we let Hay to go on, it will take another 1 hour.
Yeah, that's sure.
Because those are very important topic, which is equally important than machine learning. We do have a lot of content on that. It easily take 2 hours. Illustrate the principle of that. Yeah. So yeah, please check out our content on the YouTube or AWS blog or other place where you can see data analytic, data lake, and machine learning.
Okay. Yeah. Okay, I think there's because the time is quite hurry here. I think that's pretty much of the part 3 webinars. I think not only this is a fruitful sharing from both of you. I think hopefully we can like call up again and any other opportunities for other webinars on these kind of topics, or AWS can share more. We are definitely happy on it. Okay, so thank you all the audience. Okay, Nina say thanks very much for the share. I'm considering. Okay, so thank you so much for staying with us in this webinar. So we'll now have 10 minutes break. So please back at 4:58. You can back at around 5 p.m. So grab your time for water break or toilet break. So we will have a final part of webinars at around 5 p.m. So thank you so much for both of you sharing with us. Yes. So see you. Thank you.
Thanks a lot.
Bye bye. Hello, welcome all the online audiences back to today's part 4 webinars, the Exploring Data Forecasting, Product Recommendation, and NLP Technologies and Application webinars. So we'll now move on to the final parts of today's webinars. Our speaker will talk about the retail case sharing in machine learning application, how to train and select the ML models, and also talk about some use cases in the aspect of product recommendations. So we'll now briefly introduce our final speakers today. Okay. So our speakers today for the part 4 sections is Ming Zhang, the research scientist from Beta Lab of Linkrafter Joyce Group. Dr. Ming Zhang holds more than 5 years of experiences in the field of deep learning and big data. Ming has more than 30 publications in top international journals and conferences in the area of multimedia, big data, social network analytics, and also deep learning. He founded Multimedia Big Data Analytics Limited in 2016, based on his patent. System and method for analysis of user-associated image to generate non-user generated label and utilization of the generated label. And he's now working in the Linkrafter Joyce Group as research scientist for the Beta Lab. So let's give a big hand to introduce Mr. Ming Zhang to share with us for today's topics. So Ming, can you now share screen with us? And also, can you enable your microphone?
Yes. Can you hear me? Can you hear me?
Okay, let's wait a bit for. Okay. Thank you, Ming.
Okay, can you hear me? Hello, can you hear me? Okay. There's some technical difficulties here.
We can hear you.
Okay, that's good. So let me get started. First of all, thank you the host for inviting me for this talk. So for today, my talk will be our recommendation and model buildings. Before I start, I also want to go through some brief background of myself. So I'm a PhD graduate from HUST. Yeah, my research is multi-big data, social media, and I published some papers in this area.
So, hi Ming, can you open the cam?
Oh yeah, sure.
Okay, thank you.
Wait a moment. Right.
Okay, nice. Thank you.
Okay. So I also got some fundings from the from Cyberport, Hong Kong Science Park, and also HAI Lab. So these are some background myself. So today, I'll basically focusing on 3 topics. The first one is introduction of recommendation. I will tell you briefly about what's a recommendation and why it is useful in many different scenarios. So the second part will how do we do the recommendation actually. So I'll talk about the code filterings and also matrix factorizations. And finally, I'll also talk about a bit about deep learnings. And the final part will be about how you can build models for using item encodings and also auto encoders. So 3 parts. First part is introduction. Second is how do you do recommendation, and finally how do you really build using deep learning models. Okay, only 3 parts for this talk. So, and this is to say, recommendation is one of the most fundamental applications on any e-commerce website. For example, on Amazon, Taobao, and on eBay. no matter what you did on this platform, you will receive some recommendations. Even though you are new to this e-commerce platform, once you get onto the apps, get to the website, you will see a list of recommendations. If you have searched anything on it, say for example, in this example, you search iPhone, in it, basically you get a lot of recommendations related to iPhones, say the iPhone cases, the iPhone accessory, things like that. And second, you can have recommendation on multimedia data. For example, on YouTube, I think that this is also an experience for everyone, even for myself. Say, for example, if someone shared a video to me, maybe I'm not interested in it, but just accidentally, I click on it and got on my YouTube apps, YouTube will start thinking that I may be interested in these types of video and start doing the recommendation to me. And this type of recommendation is not just like recommending videos from the same channel, but it will also recommend the video with similar topics. It's the same for others image-based social network like Pinterest. If you like an image or ping on Pinterest, then you get recommendation of really similar images. For example, the same persons or things like that. And also on social media, on Facebook, like Facebook, Twitter, LinkedIn, if you add someone, you will get a recommendation on people you may know. One thing you may notice is that there's always a few to say that there are how many mutual friends you may have with that person. The more mutual friends you have, the more likely you may know that person. Okay, these are some recommendation scenario you will see on social media, on e-commerce platform, on different scenario. But how do we make recommendations? How can we understand all the data we have to make a proper recommendation? Think about that. For the case in Facebook, there are billions of users on them. So how can they find the right person to recommend? There's the same problem on Amazon. There are so many products. So how can you find the right one? In the past, we have techniques called collaborative filtering, which I'm going to talk about. And then after Netflix has come, they have a competition called Netflix Prize. So, and in there, they need people to make recommendations and track by the real data. And people started using a factorization machine and models. And then later on, of course, we have the deep learning models to make things like a deep collaborative filterings and etc. And the problem is actually much more complicated than people have imagined, because in this era, we are not making of data. We have too much data. So here is one of the examples. We can see here, if we talk about user-to-user connections, okay, user-to-users, that means it could be the customers of social media or the viewer of YouTube channels. They will have like a social relationship, like a follower and followee, who are friends, and they may share some similar profile also. For example, they are from the same country, they have the same preferences, things like that. Second type of relationship is user-item interactions. Say, for example, it could be like you click on certain items, you browse some channels, things like that. These are user-item interactions. Finally, the third layer is the item-to-item connections. For example, if two items share the similar attributes, then there are some connection there. Of course, there could be some external knowledges. So you can see here, there are 3 levels of connection or interactions. So there will be a lot of data to understand for the recommendation. So to do that, we'll call it a recommendation engine. So basically, the input will be all the items we have in our system. It could be easily more than million or billions of items. Based on that, you will do a candidate generations. That means we'll from the millions of or billions of items, we see that a few hundreds that they could be interested to you, and then based on that hundreds of items, we will do a ranking and recommend the item of interest based on the user and attributes and the context and things like that. The reason for doing that is that if you want to rank millions or billions of items for one single user, it will take a long time. So that's why we have a candidate set generations. And also, because you see, human cannot see too many recommendations. For example, if you receive like 1,000 items recommendations, that means there's no recommendation at all. So that means that's why we do have to rank the hundreds of items so that you will only see the top 10 or top 20s. Yeah. It's even more complicated in the e-commerce scenario. For example, if you buy you buy a lot of t-shirts, it may not making sense to recommend you more t-shirts because it's maybe more making sense to recommend you some bottom and also some shoes. So there's a lot of rules and human understand and business rules to make things work. And the recommendation process is also normally separated into two parts. The first part is what we call it the offline part. That means, for example, in Nankai case, we have a lot of purchasing history, the user demographics, informations. So based on this all information, we will try to do a learning process to make a models, to make some assumptions, business rule to make the recommendation engine works. When it works, we will put it online. That means we're really sending a DM to the EDM to the customer and see whether they are going to purchase or not. So this is a normal process we will have. So let me give you an example. So for example, now here I would like to recommend a movie. Okay, this is Star of Pie. So what I get here is that the item ID, the description of the movies, the images of the movie, the category, price, things like that. This is the movie part. The user profile part, for example, we would have like a user ID, rating history, age, gender, clicks, income levels, things like that are related to the users. So what we are trying to do here is find out the connections. But how to find out these two connections is not that obvious. You see, they are not the same type of information. How can we relate it to age, gender, to the category of the movies? That's not that obvious, and that will require algorithm to learn. So there will be a very brief introduction for the recommendation engine. And if there's no question here, I would like to move to the second part. I will talk about collaborative filtering and matrix factorization. These two are very classic algorithms for solving recommendation-related problems. So the basic idea is very simple. The first one is like I have a person here. I will see what kind of things he or she has liked, have purchased it, have browsed it. Based on this information, I would like to build a models to try to build understanding on this user. For example, if the two items he or she likes are all red, then red will become a part of his or her profile, and also circles, triangles. And then based on this user profile and understanding, I'll try to do matchings to the items that he or she has never seen before, and then do a recommendation accordingly. So these are the basic ideas of this. So the hard part here, of course, is how can you build an item profile and how do you build a user profile and make the whole things work. So one of the easiest approaches is called collaborative filtering. So to start, there will be no attributes at all. That means you don't have to take up any attributes for the items, and also there will be no attributes for the users. What you are trying to do is just like I use the items itself to represent users. If two users, they have very similar purchasing history, then I will count them to be similar. Say these two users, they all liked or listened to four music. So in this case, I will count that these two users are very similar. So for the green user, because he or she has never watched or have never listened to Muse, then I will recommend Muse to him. So the same for the red user. So this is a basic principle, okay? So the basic principle is like, I will just first of all calculate the similarity based on the direct history of the items. And based on this similarity, I make the recommendation from the similar users they found. Once I get the similarity, I'll be able to calculate based on the here, for example, this is the rating on the movies. This is the rating on the movies. Alex will, in these examples, it means that Alex will rate a Fanta with a score 1 and Matrix or 0.2, like that. So to calculate similarity, you will just like do a multiplication on one. Say for example, I want to calculate the similarity between Alex and Carol. So what I will do is to 1 multiply by 0.2 and then 0.2 multiplied by 1 and take the average. This is one of the simplest approach to calculate similarity. Of course, the reason for collaborative filtering to be selected to be used is that it's very simple. Basically, there's no feature selection needed. What you need is the purchasing record, the browsing record, and things like that. Of course, the drawbacks is also very obvious because you have to get the transaction or the weighting or the scoring in order to make the recommendations. So you will have some problems called cold start problems. That means if there's something new to the system, because it's no scoring before that, so you won't be able to make any recommendations. That's a cold start problem. The second problem is the cost sparsity problem, because the user weighting matrix is very, very sparse. Think about that. On Amazon, there will be billions items with billion users. So that means most of the item won't get any scoring. So it will be hard for you to calculate any scoring. Yeah. And one more thing to note is that collaborative filtering will suffer from we call it the popularity bias. So that's mean if an item is more popular, then it will be more likely to be recommended than others non-popular items. Say for example, e-commerce problems. Say for land covered, socks is the most popular item for most people because people will buy lots of socks and they have to buy it regularly. So if we use collaborative filtering like this, likely the recommendation will always recommend the socks, but that's not an intended behavior. Think about that. Even though you don't make any recommendation, they will buy socks anyway, and the socks is not that expensive and won't be helpful to your company at all. So collaborative filtering will have that kind of problems. So another method to do the recommendation, people will try to do the content-based recommendations. So that's mean what they're trying to do is try to understand the item first. So the learning way is that first of all, I've got the whole list of attributes for an items, and based on this attribute, I will learn a projection or learning on vectors to represent that items and try to calculate a similarity between items. So based on what you have purchased, I can calculate how much this item is similar to what you have purchased and make the recommendation or make the ranking accordingly. So this is the second method, content-based recommendation. So of course, once you talk about the content-based recommendation, that means you have to think about what are the features or what can represent an items. For example, for the case of movies, you may think about the author, the title, actors, directors, or the description of the movies. Okay, or if it is about images recommendations, you may think about, can I use the text of the images? Or even, can I use some algorithms to detect all the objects on the images and then make the recommendation accordingly? Okay, this is content-based recommendation. So that's why people think about others different methods. First of all, the good thing about this, there's no need for data on other users. So there's no cold start or sparsity problem because you're only purely using the items attributes to make recommendations. So once you get the attributes of items, you'll be able to make recommendations. Second, you'll be able to recommend to user with unique taste, because all you try to do is to match the attributes of the item a user has brought and the items you want to recommend. So it doesn't matter if a user has a very unique taste, as long as the tag or the attributes can be matched. Second, you will be able to recommend new and important items, and there will be low first rated problems because, as I said, because all you need to do is to have the attributes of the items, and the rest can be done by the algorithms. And the third, very important, is you will be able to provide explanations. So that means you can tell user why you're doing this recommendation. Maybe you can tell them for the item you have, because they have some certain attributes that match those items you have brought. And then with such explanation, the user will be are more likely to accept your recommendations rather than just a back blocks approach. Of course, with those advantages, there are also a lot of drawbacks. First of all, it's very hard to find popular features. For example, images. What kind of things are important to the user? For example, for land covers, what we are trying to do is we are trying to build a fashion recommendation engines. But the hard part here is that how can we tag and images? Of course, we have some tag for sure, but this tag affect how user design. We can use color. We can use the categories, but that's not enough. For example, this could be addressed is suitable for parties. It's not suitable for work. Then how can we do the tagging? Also, you have to find a way to build a user profile. And the third problem is over specializations. That means because all the things are related to attributes. So if an item doesn't have a measured attributes, you won't be able to recommend to the users. You may say, why there's a problem? So think about that. If two tags is actually related but not the same, then you won't be able to bridge the gap. For example, maybe there are two brands. They are all luxury brands, so they all sell similar items. But because a user only has bought one brand but didn't bought anything from the second brand, you won't be able to make any recommendation from the second brand if you're using a content-based approaches. But maybe for the user, because they are all luxury brand, maybe there's no difference at all. But if you're using content-based recommendation, you'll be limited by the tags or the features you have. Okay, and any questions so far? If you have any questions, please let me know. I would love to explain that. Okay, so this is another method. It's called matrix factorization. So in the it's originally used for Netflix data. On Netflix, people like to watch movies, and then they will weight the movies like a 1, 2, 3, 4, 5. So basically, all they will have is a matrix like this. A matrix like this. This is item, and this is users. This means is that a user has weighted this movie to be 1. This user has weighted the movie to be 3. This user has weighted the movie to be 5. Okay. So what this is, we call it an R matrix. For what we're trying to do is find out the representation for the items and also for the users, like this. So if I just multiplied this vector with this vector, I will get I will be able to predict the score for certain users on that movie. Okay, so this is the principle behind what they are trying to do. So this method is called matrix factorization. So basically, we're just trying to find out the two factors that can represent the users. When we get these two factors, very simple. To make a ranking for that, we just calculate the score for every empty item here, empty score here, and then just rank the score accordingly. Okay, so it's just like this. If I want to get the score of this point, I'll just find out the vector of this user and this item and multiply them together, and that will be the predicted score of that part. So this is a matrix factorization. So the good side of this method is that you will be able to get the representation of a user and get the representation of the items. And even though that user haven't weighted that item properly, you will still be able to predict the score based on this profiling. But of course, the drawback is also obvious because if you want to learn something about the user and learn something about the item, you have to get some score to start the whole things. So there will be a cold start problem for a new item or for a new user. They won't be able to get any vector at the beginning. And even though they got some scoring at the beginning, it won't be that accurate because they have to get more and more data to make the vectors and the more accurate. So finally, we will come to the deep learning part. So the deep learning part will be like this. They will I'm not sure if everyone is familiar with deep learning, but deep learning is just you can say the whole thing is just a function that you can input anything, basically anything to it, and give them a learning objective. And in between, you're trying to learn some representation so that whenever you give a similar input, you're trying to predict. You're trying to predict what you want to predict. So basically, for deep learning approaches, what you're trying to give here is just a user profile. Say, for example, it could be count, it could be their means, standard deviation of consumptions, the income levels, the demographic information, things like that. And the item information, it could be, for example, in car, it could be like consumption and things like that. And you have two different networks at the same time. This one is user net, the other one is the item net. So they will do some learning and basically output called embeddings. One is user embeddings and the other one is item embeddings. And these two embeddings will embed together into a rank net. This rank net, we try to calculate the probability that this particular user will buy these items. So the idea is like this. So basically, first of all, you got a lot of different data for a single users. So you try to make use of all this data to find an embedding of the users. You got a lot of information about the car. It could be the all the attributes and things like that. And then you trying to put into the what happened? You're trying to put in the deep learning network to learn an embedding. So basically, it's just a vectors. So now you got a vectors for each user, and you got a vectors for each items. And then you put this vector into the rank leg, and basically it will tell you the probability that this user will buy these items. So if you do that for all the users and the items, you'll be able to rank all the items and make the recommendation accordingly. So in order to do embeddings, there are a lot of ways to do so. One of the most important ways is called the autoencoder. It's called autoencoder. So what you're trying to do is just like you input items, you're trying to learn an embedding layers such that this embedding layer could be used to reconstruct the original items. Yeah, to reconstruct the original items. So when they do this learning, what they try to do is the network will try to generalize everything. If two items are similar, they will get a very similar embeddings. If two items are not similar, they will get, of course, they will get different embeddings. So based on this understanding, they will learn the embedding levels, the embeddings for the items and also for the users. Okay, so for all the information using to learn the embeddings, of course, we'll have one set of information. We call it explicit representation. The other one is implicit recommendations. Explicit recommendation is what like the gender, the demographic informations, and things like that that could be directly understandable for the users. But the bad thing about this information is that it's hard to obtain the training data because the user won't tell you who they are, and maybe they are just logging the scares to buy something and then they are gone. And sometimes this information may not be enough to represent the users. And the other one is implicit user representation. This means they use you use different source of information to represent the user, like the images, the text, and then you provide end-to-end learnings to represent the users. Of course, the hard part is if you use the image to understand the user, you may not be able to really tell why the user is like that, why they are similar. But you will be able to learn much more about the user. These are some information or basic user representation. Okay. So basically, it's just like everything that could be well understood by human and could be well learned by the models. And as I shared before, the learning will consist of a few parts. The first part is the offline part. That means you use all the data you have to generate hypotheses, and then you train the model, and then you evaluate the models using offline data. Once you get the certified results, then you will enter the second phase. Is called an A/B test. This A/B test will be like, say for example, if it's in EDM, you will first of all, you separate the user into two groups. For the first group, you will send using, like, for example, the old algorithms. And the second groups, you will use the new algorithm and see how they respond. If the second groups give you better response, of course, then you can enter the rollout phase and redeploy it for later use. So this is called A/B test. We just keep everything the same, but sending the recommendation using different algorithms and see the result, and then decide whether or not, and to see whether we should adopt these new models. Okay, so there will be just a very brief introduction for collaborative filtering and also matrix factorization. So, and now I'll go to the last part for the model building, the item encoding and auto encoder. This final part will be more difficult. Will be a bit more difficult. So, in case you have questions, please feel free to ask me. Okay. So, what's an auto encoder? One more point here is that this part will require you to have some basic understanding for deep learning models. Yep. So what's an autoencoder? To start, that means this model, normally for deep learning models, we will always have a goal for the predictions. For example, if it's a classification, so basically I'll give an input X and then I'll ask to predict the output Y. If this is a classification model, say for example, to predict cat or dog, and the inputs in the images. So for long mode deep learning networks, I will give an images, and then the model will predict like this is a cat or dog. Okay, so this is classification. If this is regression, I would like to predict, like for example, the Hang Seng index for the tomorrow, for example. Then the input could be like the trend for today, and then you try to make a prediction for tomorrow. Then this is a regression task. But for autoencoder, the target is different. The inputs could be images, it could be vectors. So what we're trying to do, is just like, first of all, I will compress this input to a vector, and then I will use this vector to reconstruct the output. Reconstruct the input. By doing that, I will be able to learn with good representation of the original data. So first of all, if it's an images, now I got a vector, I will easy to store it. I'll be easier to compute the similarity between these images and also other images. So as I say, we can map high dimension data to 2-dimensional data for visualization. For example, we can make images, or we can a set of images into 1 dimension to be 1 vectors, and then calculate similarity among different images. We can do compassions, because now I don't need to store the images. I can store a vector to do comparison. And also, autoencoder doesn't require any labels. So basically, it's unsupervised learning to help you to learn. So I feel there's a lot of advantage here, but they will require a lot of work to make things good enough for deployment. For example, first of all, you need to do a problem definitions. You do then you find out what the problem is with the business users, to do a lot of meetings with them to understand their needs, because the business user won't understand the technical process. What they have is just a problem, and they don't know whether their data can solve it, or even the problem is solvable. So here you need to define the problems, you think about how the technology can solve their problems, and then you need to start the data connections, and then you do the model training and then the deployments. In model training, you need to spend a lot of time to try out different model structures and train it to see whether you can get a good result or certification result. And it will take a lot of time. And it is actually, I will call labor-intensive work, because you're going to test a lot of different models, and each one will take you a lot of time. And the most demanding part is like when you think of a new structure, a new for the models, you click on the training buttons, and you have to wait maybe 1 hour to see the result. Okay, and if you train the model, and then you may need to repeat this process for 10 or more, even 20 times. You just sit here, train the models, and then click enter, and then wait 1 hour to see the result. And sometimes if the data is even bigger, it will take me like 1 day to complete just 1 model training. Then there will be a problem. So to do that, people will formulate how to do a model structure as a hyperparameter tuning problems. You can think about that. This like people would like to use an algorithm called Bayesian optimization. So to start with, think about that. You try out different. This X is like the number of layers you have in deep learning, and the y-axis is a result you have. So now you have tried 3 different models. So different setting, you got 3 different result for that. So in order to find the best setting for that, you make use of these 3 points to find out which would be the next point to test. That will likely to give you the best result, and also to give you the best result. So you propose the next point to test it out, and then you update your functions, and then you find the next best test case, and then you do the testing. You do the guessing accordingly, and then finally you will be able to find the best structure. Okay, I'll skip this one now. So the method or the library I'm using now is called AutoKeras. It's called AutoKeras. I assume that most of you have tried that TensorFlow, and now TensorFlow has included a library called Keras. Keras is a deep learning library that will help you to build models, and it's also easier to use. And someone has built a library called AutoKeras. It's also, based on the name, it's based on Keras, and use a very similar style as a Keras for the program writing. So what we're trying to do is just like if you want to build a classifier like this, build a classifier, image classifier. What you need to do is just noting the X string that's in the images, and then give the labels, and then the library will do all the model building for you. We'll do all the model building for you. Okay, when you have built a model, what you need to do is just predict and then get the result. So simple enough, all right? So these 4 lines of code is actually AutoCaras will help you to build an image classifier. You just need to specify that you are using an AutoCaras, and then you do the fitting, give the training data, and then it will find out the models accordingly, and then predict, and then you can do the prediction already. So the idea is the same as Bayesian optimization. So what you're doing here is just like they will try out different models. So basically, they will calculate the distance between different models and try to predict which one to try next. Yeah, I will skip this for the moment. The method they are using is more like a graph search. More like a graph search. But I will skip this for now. So if anyone is interested in this, the detailed algorithm, please let me know. I'm happy to share this part for you. So that's all of my presentation. So please let me know if you have any question here.
Okay, thank you, Ming. Thank you so much. So, okay, let me do the share screen now.
Thank you.
Okay, so we'll now enter the Q&A and networking sections. So if you have any questions regarding on Ming's content, or you want to know more about NLP, data forecasting, product recommendation related technology, or if you have interested about, especially on maybe the Linkravit Joyce group informations, you can now ask in Q&A first. So we will refer your questions to Ming. Okay, I think Ming, you can now see some questions popped up in the Q&A columns, right?
Yeah, I can see check, right?
Yeah,
okay,
yeah.
Question. Okay.
Yeah.
Okay.
Maybe you like verbally answer it. Okay, so the first question is, other than adding more data, how can the accuracy be increased?
Oh, okay. The first for this question, there are actually it depends on the situation. For example, if we are doing regression tasks, for example, we spend a lot of time to do the customer lifetime value predictions. Okay. At first, without doing any data filtering, the result is very bad. But when we do some investigation on the data, we find that actually the result is bad because a lot of users will just purchase it only once, and then they are gone. If you try to build a model for everyone, okay, for everyone, then that means that the data for certain, it will be biased to predict 0, or just the initial value for that users. So in that case, I would suggest that the engineer to separate the data first. So this user, they are going to only purchase it once, so it's not that matter to predict their customer lifetime value. The other part of the customer, they are going to buy a lot of time, so we should build a model to predict accordingly. So to do data investigation is also very, very important. So we call it the data analytics, to understand the data and see why they have such a behavior. And second, and the second part is about the result. Once you build a model, you should build the confusion matrix. You should build the confusion matrix. That means to see the differences between the ground truth, the differences. Say for example, you have 3 classes to do classification, and you see how many of class A. I mean, how many items that should belong to class A have been predicted as class B and class C. If you see that there's a high number of class A suddenly being predicted into class C, then that means there's some problem or there's some similarity between them, and you have to do some feature engineering to separate them. There are some tricks we can do. Okay. So do you have limitation as a scientist?
Okay, do you have limitation as a data scientist when you must work with different departments on a project, especially when I guess maybe if you're having a project, you include different another departments, especially like I don't know, like admin, HR, or other business side departments.
Yeah, I mean, we are lucky enough because as a beta lab is actually a subsidiary of the Infrastructure Group, 100% subsidiary. So that means, and we are responsible that we are reporting to the director direct. So in that case, we have enough authorities to talk to different departments, and also we have access to all the data we want to access. So I think for me, the hardest part is that different departments will have their own languages. Okay, for example, for HR department, they will have their own concerns, understandings, and things they want to do. And you have, yeah. And for example, for the sales or merchandising departments, they will have their own concerns and problems. So as a data scientist, you have to be able to understand their languages and help them to translate them to technical problem that can be solved by your tools. That's the hardest part, I think.
Is it difficult to persuade other parties to adopt your suggestion as you talk about, like if I'm a newbie, I'm not a specialist in especially for data, I may like having judgment on your suggestion, or I may only consider the cost like bigger than anything.
Yes. We also have the cold start problem. If it's the first time we work with a new department or a new directors of a department, with all that problem, why they should trust us, right?
Yeah.
So in our case, what we're trying to do, always trying to do, is have a dashboard, something they can visualize, at least because we have access of all data. So the first part is at least they can visualize something, their data, that can help them to make decision. So that's always a good starting point, because they will see how it works and how the data can help them. Once I would say when they're hooked, then we'll be able to do more, do a larger and more useful projects after.
Yeah, agree. Okay, so this is a fun, interesting questions. Also, what's the practice for the Lancaster-Joyce Group product recommendation engine when encountering the cold start, like in terms of new product or visitor?
Okay, so these are two questions. So for new visitor, yeah, for new visitor, because we have a lot of different engines actually, models actually. One of the models we have is called a similar product engines. So that means even though it is a new items, or new products, because we have a similar product engine, we'll be able to calculate the similarity between these products and the products in our existing stock. So once we do that, so this is not a problem, because we can use the images, we can use the descriptions, we can use the attributes to project that new item into our vectors, and then we can do all the recommendation engine accordingly. Actually, this is quite a limitation in our case, because we are a luxury brand. We also sell jewelries. So for jewelries, normally there will be just like 1 or 2 items. At most. So they are all new items to us. So that's why we are always using the images and also description or categories to do the embeddings and then make the recommendation accordingly. For visitor, then if they haven't logged in, then they just get the list of recommendation for the item they are browsing. Or if they provide any information like their genders or things like that, we'll be able to do recommendation accordingly.
Like I have one question follow-up, like you talk about luxury or jewelry that maybe a small amount in items, maybe only 1 or 2 available in the market. But any other feature, like can can I reference this, for example, oh, this jewelry is made of marble. So can I reference this feature in the market? Like how many consumers eager to buy the marble product, or this color is Tiffany blue. So how many consumers out there are really searching for this kind of color? Can I like crossing with this kind of features?
Oh, first of all, if you talk about what are popular in the market, I think that will be like a merchandising problem. And yes, there we're doing some solution for the merchandising team. We will we call scraping. That means we are collecting data online and see what are popular out there. Yes, we will do that. And also we'll utilize external data. For example, if it is a jewelry, we will collect data from other jewelry seller, and try to make use of these jewelries to tag the images in our system. Yeah, we will do that also and try to make the attributes richer.
Okay.
It will be the same for fashion item. Yeah, for sure.
Okay. There are a lot of ready-made solution out there. So why is your company investing in the data team to create custom solutions?
Yes, we do that all the time. And basically, most of the time, we will try to do it ourselves. Well, how can we put that? So we have talked to many different solution providers, to many, really many. If we can try, we can find a solution, of course, we will adopt it. There's no reason to build it. But the problem is, say for example, for fashion tagging, there are a lot, many existing solutions out there, not just in Hong Kong, maybe in USA, in India, there could be a lot of different solutions. But the problem is, when you look at the attribute list they have, when you look at the attributes they have, they doesn't match our item. They doesn't match our item. Because normally, when we try a solution, we will find out a lot of images from our collections, okay, and try to see what are the results we get back. And if the items is like to find out the like if it is a shoes, or if it is a top or a bottom, yes, it's okay. But if we talk about when you want to use this tag for recommendations, like for example, it's suitable for parties, and it's suitable for a dinner, then there's no hope out there for the moment.
Okay. Audience can still ask question if you have any inquiries or question on the business of the Link Profit Joins Group, or you want to know more about Link, you can still drop questions here. So, okay, by far I have one question myself. There are growing more number of businesses want to use ML or such kind of technology. So most of them will ask like, how long can I see the result of implementing such technology? Like take how long time for me to return, like ROI return on such case, or after several months of implement such technology, what metrics or how can I evaluate such models for our business?
Okay, so let me give you an example in Profit Joins. So we do a lot of EDM. So basically, we send EDM to our customer regularly to give them our recommendations, do a mix and match or things like that. So normally we will have several metrics. First one, of course, is a click-through rate, whether they open our email. Okay, this part is also important because that means how good is your title is. So that's why whether they open it. Second one is of course whether they are going to purchase it, or are they going to purchase other items? So basically we have different layers of metrics, one by one, from the openings to the purchase. So we will see which layers is performing well and which layer is not performing well, and we will do comparison and try to evaluate what kinds of things are missing from there. Yeah.
Okay. So I have another interesting question, Paul. Like in the past few part of today's webinar, we have different solution provider or like cloud platform, etc. They all provide like ML solutions. So for Beta Lab or Link Private Joyce Group, what are your ML models so different compared to maybe some of the other ML solution provider or vendor, especially in the market? Like, especially you mentioned you have a team to build it tailor-made. Yeah.
I think it's because we are lucky enough. Link Choice Group, even before Beta Lab, they have because we have, Link Choice Group has stored a lot of purchasing information for the products, and we also have a very professional teams to tag all the items we have on Link Choice Group. So, by the nature of our parent companies, we have very rich informations for many years. So these are the advantage. We can start from there. And also because we are inside Link Choice Group, so we will be able to talk to different business user, right? And because we are under the same umbrella, so we will be able to get a lot of insider information. We will know how the merchandiser really how they design, what kind of products they are going to purchase for the next 6 months, and how the or even the HR department, how they design, whether they select certain candidates, things like that. We all got this information from the insider. Once we got the information from the insiders, and we got the data, and now we have Beta Lab, so that's why we are able to build the best. Well, not I say the best, but we are going to build good solution for retailers. That's what we do.
I think that's quite strong, as not only you have a very long history of data in like purchasing history of different consumers, you even have like you mentioned, you even have the suppliers or different kind of other stakeholders, parties data, which really makes it, yeah, although I'm quite new in this topics, but I can understand how strong it could be. Yeah.
Yeah, but so I say that we are lucky enough to got all these data and also business users, access to data and business user.
Okay, what are some questions from audience? What are some unique challenges you have faced implementing ML solution within the companies? Like other than those you mentioned, like the some of the fashion items you have not much information or data on it, like any other challenge you could elaborate?
Of course. So even those we don't have we have access to data because there are some legacy issue, then we need to deal with a lot of different forms of data, right? I mean, because at the beginning, no one has thought about how useful the data is. They just store it, and they just store it maybe separately for different items and things like that. In that case, we need to spend a lot of time to understand the data and also how to integrate them together and try to build something useful. Of course, we are always using a lazy approach, trying to build different model for different set of data for the same problem. Of course, we can do that, but that is not a long solution. But so, in my opinion, the hardest part would be how we handle so diverse of information and to make the ML model works.
Yeah. Okay.
And
okay, this is quite yeah.
Well, for me, I will view this problem as an opportunity, not a challenge. Yeah, the reason is that because even though this is cookieless, but Google still provides something for us. They call it cohort. That means for each user, or each com user, they will provide a numbers to indicate the interest of that users. Okay, so that means if Google thinks that maybe these users are having the same interest, they will be using the same ID for us. So based on this ID, because we will have online the browsing information and also purchasing information, so we can easily map this ID with the purchasing record we have, and then we can do recommendation. So even though this is a new user, we can make use of this ID to make recommendation based on this ID. So for us, it's more like an opportunity.
Yeah.
Rather than a challenge.
Okay, so so I think cookieless world is one of the upcoming trend or things we have to adopt or overcome. So any other trends in ML or such technology you think the future or what's your imagination for the prospect of or future of like how this technology will be evolved, or like how can it further implicate into more other industry like other than e-commerce or such kind of industry?
You mean cookieless?
Or
ML?
Or ML, or both?
For ML, I think the next trend will be like we'll have an auto ML. That mean you for now you will require a data engineer or a data scientist to build models for certain data. But I think in the future, it will not be a human task. It will become a computer task. Human tasks will become like to communicate with different parties and departments to understand the problems, and then it should translate the problem into something that the machine can understand. Then that's it, and the machine to do the rest. Yeah, of course. In the future, maybe this part could be replaced by machine also. The machine can understand the requirements and generate features, and they understand the data and generate the models.
But is it still irreplaceable for humans' position or role in the whole, especially for ML cycle?
I think it's still essential. For the first of all, it's the beginning. It still need a human to provide the project requirements, right?
Yeah.
And finally, you still need human to track the result, because AI is still not perfect, at least today. Yeah. So is this okay?
Is it necessary to train a new model for like different customers?
Normally we don't want to do something like that. Yeah, unless say for example, if it's different brands, or even though this is different data from different companies, then we will need to train different models. But normally one model should be enough. If the data can be normalized, we will say.
Okay. Okay, when do you think the AI singularity will arrive?
I'm not sure. I don't understand what's AI singularity.
Maybe like is he or she related to like AI
taking over humanity? I don't know.
It's a bit horrible. Sounds like. Okay, you can like further elaborate more on it. Yeah, what's the AI singularity? I mean, our audience. Yeah. So Ming can get back to you later on this question. Okay, so I will now enable the chat room functions to all the online audience. So if you have any questions you still want to ask Ming, okay, self-learning AI, which can self-improve.
Self-improve. If you are talking about if you are talking about say build models and whether it can improve itself later, then we have it already. But if you're talking about AI, design AI, yes, we have it already. But we don't have some. But luckily, we still don't have some AI have a self-conscious.
Oh my God.
Yeah, but you say that you want AI to design AI. Yes, Google has that already. Yeah. So basically, I think what they can do is just like you give your project description and they try to learn. They try.
Do you think AI have self-conscious is a like is a like tremendous or powerful tools for like different works or tasks?
I think it will happen anyway.
Yeah,
because you see, the AI. The architecture of the AI model is actually the same as human brains designs. So by providing the enough computation power, I think it will happen sometimes, or not. It's a matter of time.
Okay.
Yeah, and yeah.
Okay, so I have enabled the chat room functions. So please feel free to drop your questions if you are interested about such topics, or you want to know more about Main's daily work or his challenges or anything he encountered in his work, or if you want to inquiry on or conversate with Main, just drop your questions or anything here. Okay. What was your PhD thesis? What are the common parameters in running ML model for?
Wow, there could be a lot of questions here. Okay.
Yeah, some of those are the previous questions in the previous part.
Okay. Give me a moment.
You can like feel free pick some to or chat with some of our audience here.
Yeah.
Yeah.
Give me a second.
Okay. Or you prefer to like verbally told him or her? You can like put. You can.
Okay.
Yeah. You can do it in any way. Yeah.
Oh, okay. So what are the common parameters in running ML model for retail personalization? Normally, it will be about how to build a good model for that. But for our case, I think it's more on the feature engineering. How do we present the users and understand the behavior of the user that take longer times than just setting parameters. Because for parameters, I can always use the auto ML method to solve it. What was my PhD thesis about? My PhD thesis is I try to understand the user behaviors on social medias. You know, a lot of people share their images on social medias, and based on these shared images, I'll try to understand the user. Say, for example, whether they are understand their genders, their nationalities, who are their friends, where they are from, things like that. And what are some good areas to study in terms of ML? I would say for now is reinforcement learning, certainly, and
why this is so valuable to tap on, like reinforcement you talk about?
Because reinforcement learning, first of all, is this is a deep learning topic. Second, because this is related to AI. It is a topic tell you how machine learns and behave accordingly. And there will be a lot of applications. Say, for example, you can do this for like a self-driving car. Is using a reinforcement learning.
So when I have a question personally myself. So when I saw your backgrounds and also bio, I recognized you have did so many research, and also you have published a lot of like 30 something publications. So what are these publications giving you any interesting insight, or how can can you share some of the interesting topics you have ever researched on or you worked on before?
For that, I think I learned how to learn based from the papers, because you see the papers is like a few years ago. So in this field, things change up every 1 or 2 years. So after 1 or 2 years, you look back your clock before, then you will find that they are all outdated. So it really doesn't matter what you learn now. It really matters how you learn the future things, because this field is updated so fast. Actually, even for myself, after my PhD study, I'm still reading one paper, at least one paper a day. Try to catch up everything in the field. Really, that's so much information to learn.
Okay, feel free to drop your questions or chat with Ming. I think we still have 4 to 5 more minutes before the end of this part. Okay, I see Alan Kuhn. Okay, what are we missing to achieve a general AI?
Missing in natural general AI. This is a very difficult question. In terms of ML terms, I would say this would be like a feature engineering problems. So given the generic problems, like how do you learn the features from this generic problem to match the things you have learned before? That's a hard part. For human, we can easily like say for example, my first programming language will be C++. So when I start learning Python, I can make use of my experience from C++ to improve my Python. But how can we do that in ML, in learnings? Yeah. What features that the machine can learn automatically? That's the hard part, I think. So how can we improve the accuracy of ML result in forecasting? Well, I think that is case by case, but generally, if the result is not good, first of all, I will do data analytics to see the data distributions, see whether there's some string distribution in data, are the data noisy? And this is always the first things I track. Normally, if your data is good, even though you use the most simplest model, say support vector regressions, even though you should be able to get something. And
in terms of any if I insert some poor or totally not an irrelevant data, is it difficult for to remove or uneducate the machine learning model on this kind of dirty data or raw or unstructured unrelevant data?
In that case, if the data is polluted and you train the model, in that case, we will suggest you to retrain the model from the scratch. Yeah, okay. It's not that easy to remove.
Yeah,
to remove that. Yeah.
Okay.
And the data analytics part is actually used that for one of the reasons for to do data analytics is to understand the data and also to do data removal if necessary.
Yeah. Okay.
What's a major breakthrough you think ML can solve? I think well, I think I'm not qualified for these questions. I'm also exploring the field. there's so much to learn now.
Okay, so let's take Kenneth and CS Lee as the final questions. Okay, so for Kenneth, how to, okay, is it general for Ming to answer how to evaluate and choose a model for ML? Like any golden rules must follow?
Yeah, of course. The first one is, of course, data. First of all, of course, assume that you understand the data fluently and you do a proper visual engineering. So the first part is, of course, the first thing you need to see is if you see evaluate and choose the model for ML. Well, that's also case. That's also case by case.
Yeah.
As I say, if you say you're doing a regression problem, someone will use like a mean absolute error to measure the accuracy of your prediction, mean absolute error. But in that case, this mean absolute error will also bias. We also bias to small value. On the other hand, if you use like a mean percentage error, then it will also bias to small value. So I think there's no golden rule that you can apply to any situation. For all you do is to do analytics to see the behavior of the data and then make the choice accordingly.
Be flexible and case by case, right?
Yeah, I think that's still the part that a machine cannot replace human.
Yeah.
For now.
True.
For now. Yeah.
Okay, final question.
Quantum computers. I think that will not happen soon. Because for quantum computing, they are using actually not the same ways to do the computation. So in order to make quantum computers workable, they will have to start all the design from the beginning. They have to do all the design from the beginning. So that means they have to change all the computation method for deep learning libraries, things like that in order to make it work. So I think it won't happen in a few years, at least. But if it happens, then I think, first of all, maybe a lot of passwords will be cracked. Yeah.
Okay, I think that's pretty much of today's webinar. So, okay, thank you so much for Ming from the Beta Lab of Landcrawford George Group to present with us and also answer a lot of questions from our audience. So thank you so much for joining us today. And yeah, thank you. Okay, see you, Ming. Bye-bye.
Bye-bye.
Bye-bye. Okay, so we will soon enter the final part of today's webinar. I will do a quick summarize on today's webinar content, how it benefits to all the online audiences here, especially on understanding the knowledge of how to explore data forecasting product recommendation and NLP technology and applications related to the mentioned technology. So we now have 1 to 2 minutes break. I will set up this venue again, so I will back very soon. Okay, we are back. So thank you very much for staying with us in today's webinar, the 6 hours webinars. So here's some of the ideas from our speakers today, mentioning about how these kind of contents can be relevant to you and beneficial to you. So from our first speaker, Sunny Wong, the Director of Product Development of Sexcel Software Limited, he said, NLP, natural language processing, helps machines to understand unstructured text data that represents their thoughts and ideas. So let's see how NLP can empower your applications to be able to interact with users more naturally. For our second speaker, Terrace Pond, the Vice President, Business Consulting Department of Fano Labs, he says, language AI solutions help companies to provide round-the-clock human-like service to customers by automate tedious customer interaction, as well as identify area to grow the business through the engagement with customers. So let's gear up and better serve the now customers. For our first speaker, Chow Wai-hei, He Chow, and also his colleague from the AWS, they mentioned that ML on AWS actually helps you, especially the online audience, make accurate predictions, get deeper insight from the data, reduce operational overhead, and improve customer experience. So it's not bad to, if you want to implement into the ML technologies and you are lacking solution provider or platform, you may check out this kind of solutions mentioned in this webinar. So for our final speakers, Ming Zhang, the research scientist of Beta Lab of Lane Crawford Joyce Group, he says the recommendation has become a basic element on any e-commerce platforms, from food ordering to online shopping. But how to make an accurate recommendation is like a black box, and it is hard to improve it without understanding it. So this session actually will help you to understand recommendation and how deep learning can support it. So I will now summarize a bit on today's content and knowledge we have. Our guest speaker has brought to you, such as we learn about the knowledge related to the application of machine learning, data forecasting, product recommendation, NLP, etc. Our speaker covers on the retail case, especially in machine learning applications, some of the process of running an ML project, including such as data collection process, the construction process, how to data cleaning, data mining, and how can you frame the problem properly before you really start to implement everything. Also, how can you further improve its accuracy of data forecasting? What should you do? Our speaker also covers some of the real demos of how such product recommendation system can be used in e-commerce or retail's different kind of industry. And we also talk about the ethical issues behind the machine learning. So thank you so much for joining us today. And please fill in this feedback form. Please drop your comments and feedbacks by scanning the QR code here. And your comments and feedbacks actually help us to improve further event arrangement and also the event logistic or the event content. Your feedback definitely helps us to improve the quality of the whole event. So don't hesitate to leave your feedback to us. So we'll now stop here, and please scan the QR code and use the rest of the time to drop your feedback and comment to us.